In this video, I'm giving you a full 3.5 hours worth of Python automation project. We have a total of 26 Python projects to go through in this video, starting from very basic ones, going all the way to resume-worthy projects towards the end of the video. We have everything from standard automation topics like email automation, file automation, to some very interesting applications in things like automating your personal finances, time management automation using several APIs, as well as some fun projects where I, for example, build an automated Tinder bot to automate my online dating using web scraping, as well as some very advanced projects, for example, a fully fledged machine learning project, which we build right at the end. So whatever you're interested in the realm of Python automation, this video is definitely going to have at least one project for you. I'm going to have all the projects listed down below in the timestamps on the video, so you can just go and search them up, see what you are interested in, and follow the tutorial as you go. And then you can come back to this video if you're ever looking for more Python automation projects. And just for clarity, this video has been compiled from Python project tutorials that I have made on this channel before over the past 2 or something years, because there's many new viewers on this channel that haven't even seen a lot of my older tutorials that were extremely popular. So I've just compiled them all into this video, so this can be the only resource that you need to come through if you're ever looking for Python automation videos. And with that said, before we dive in, if you're at the stage of your Python learning where you're not really ready to build all these projects yourself, you're not sure how to build projects from scratch, you don't really have all the Python foundations under your belt yet, then I also have my full paid flagship program, Python Developer Bootcamp, which I will leave down below in the description, where we have more than 600 students and amazing reviews, where I take you from complete beginner to an advanced employable Python developer in less than 6 months. We go through all the technical skills you need, as well as a full bootcamp on actually how to turn these technical skills into a real job in the real world as a Python developer. So if you're looking to not only learn Python, but also get a job with it, and you're looking to go through a program that's been proven to work for hundreds of students, then I will leave a link to it down below in the description, and you can use the code Python for a discount on the program. And with that, let's get started with the first project. So what our goal here is to do is that I build this program, which don't worry, we'll get into how I've done all of this. But when I actually run this program, and while it's running, what I want to happen is that whenever I download an image, instead of it going into the downloads folder, it's going to be sent to this downloaded images folder. And whenever I download a video, I want it to be sent to the downloaded video folder, for example. Let's say I'm downloading this image of the like button, which you should hit, by the way. So as you can see, I downloaded it right there. And when you go to the downloads folder, it's not there. And if we go to my downloaded images folder, it's just gone to the image folder. So this is the goal that we're going to be doing here. Okay, so let's just talk about how I sort of think about approaching this. There's obviously a lot of things you need to do. You need to have the file running, you need to have it sort of listening to changes in the downloads folder, and then you need to basically, based on the file type, have the program send it to the appropriate folder. So there's a lot of different things that you need to figure out, and once you start a project like this, you won't really have an idea of doing either of these things. So where do you even start? Well, the best way to think about this is to not even worry about all these things at the same time. Well, one way you might think about it is like, okay, what is the first thing we need in order to have a program that basically moves files around on my computer? The first thing I thought is that, first of all, we need a way for our Python code to access files in our computer. So that's the first thing we're gonna figure out. And so how are we gonna figure that out? Well, just like any programming problem, you go to Google, you go how to access files on Mac using Python or something like that. And basically this is essentially what I did when I was coding this up. I think it was this article that I found where I found that, okay, first of all, I need to import this OS library. So we're gonna do that. And then with this library, if you use this scandir method, we can essentially return a list of all the files in that folder. So we're going to be doing that. And so if we define the folder that we want, what we can then do is a basic for loop on this entries list, which is essentially just a list of all the files in that folder. So we're going to go for entry in entries. Basically, this code is going to be run for each object in that list, where entry represents that object in turn. So if we just try running that, we're going to stop that. Python, and these are essentially all the names of all the files in my downloads folder currently. Okay, so now we've achieved something. We found a way to access the files in our downloads folder on our computer. First step done. Now we can start worrying about the next thing, which is like do something whenever there is a change in my downloads folder. So whenever a file enters my downloads folder, well, you're gonna Google that as you do with anything. And essentially what I found is, well, there's probably a bunch of ways to do it, but one way is through this watchdog library. So you're gonna install it by going to the installation page. You're gonna copy this. If this doesn't work, you might want to try doing pip3 install. It depends on sort of the version of Python you have and something like that, but essentially you would go through that, you would press enter, it would install it. I've already done it. Now we have our library installed, and essentially what this library does allows you to listen for changes in your folders, which is exactly what we want. And I'm going to leave all these links down below in the description. I do recommend that you go through them in more depth if you want to do this so that you fully understand what you're doing. They usually have some sort of starter code for you to get started. Yeah, you just copy it. It's going to tell you all the things that you need to import. Essentially all of this code, which now we can go over to my actual file, I guess. I've got it down here. All of this just initiates all this process. You don't even need to know what all of this does all the time. The only thing you need to change here is that for this event handler variable, you're going to set it to equal an instance of this class that you created yourself, of this mover handler class. This could be called anything. This should be called hello. And then in here, you would just go change this to hello, like that doesn't matter, that you can define yourself. And then the other thing you need to do is for this path variable, you need to set this to equal the directory that you want to track. In this case, I want to track changes in my downloads directory, and in here I've set path equals source directory. So these are the only things that you need to change in this piece of initializer code. So once you've done that, essentially what happens is whenever there is a change in this source directory, which is my downloads folder, it is going to fire the unmodified function of the mover handler class, which is a subclass of the file system event handler class. That is the requirement. That is what happens once you got all this set up. Now we need to start defining the actual code of what is going to happen when there is a change in this folder. So now we get to use the scanning the directory code that we figured out earlier, as we did before, with os.scandir, and in here the source directory that we want to track as entries. We're going to do a for loop for all of the files in that folder. And then there are all these if statements. For example, if you're looking at this piece of code here, if the name of the file, remember we're going through all of the files one by one, the name of the file ends with .mov or .mp4. These are the most common ways video files and the most common video file types. What we're going to do is set the destination folder to be dest_dir_videos, which will be defined up here to be this folder. And again, this is what you would define yourself. You would define where you want all your video files to go, for example. So we're going to define that as the destination, and then we're going to run this move function, which is something that I have defined completely myself, and that is up here. So what is going to happen is going to take in the destination folder, which we just defined, and it's going to take the entry, and it's going to take the name of the file. What happens here is we're first checking for whether that file already exists. So we're going to get to that in a second. But if it doesn't exist, so if file exists is essentially not true, it's not going to run this code, and it's essentially going to go to this shuttle.move. And this is again another thing which I had to figure out by Googling. Now that we know how to access files on our computer, how can we, through our Python code, move files in our computer from one directory to another? And the way we do this is using the shuttle library, which the only way I know that is just by finding it on Google. I'm just saving you the trouble by showing it here. And this shuttle library has this move function. So what this is just going to do is move the file in the destination folder. And that essentially completes what we want to do. And then we just do the same thing for images, where if it ends in JPEG or PNG, we do the exact same thing except for these images or this downloaded images folder. And that's what you saw happening earlier when I was downloading that like button image. By the way, if you enjoyed this video, do hit the like button. The only slightly more complicated thing was for music and sound effects, but then music and sound effects, you have the same file type, so I had to figure out how I could separate them. But this is not perfect, but essentially I went, if the size of the file is less than this, I think this is like 250 megabytes, or if the name of the file as SFX. So I found a lot of the sound effects I was downloading, the name included this SFX string. So if the name includes SFX, or if the file is small enough, it's probably a sound effect rather than music. So in that case, I would move it to my destination sound effects folder. I could keep doing this for PDFs, for docs files or whatever, and I probably will, but this is just the version I have now, and it serves more of the purposes that I need it for at this time. I am going to leave this exact code in the description box, where you can essentially use this exact same code if you want, or obviously I encourage you to do this yourself as well, because it is a very great exercise on Python and actually building something for yourself that you actually end up using for yourself, because actually building a program that I use myself is a really rewarding feel. Like, I built from scratch a program that actually is helping to solve problems for me. That's a really nice feeling. Whatever thing you can think of that you're doing on your computer all the time, over and over again, some like mechanical task, there's probably an easier way to do it with code. And so I just challenge you to try to think of these things that you might be able to automate, and then just go on Google, type on how to do X on Python. And so that is how we learn. And building something that you actually use yourself is a very motivating and a very rewarding way for you to get better at coding. Whenever you want to run it, what you can obviously do is just cd into the folder and then run the actual program. But you'll probably find out that defeats the purpose of a lot of the automation if you then always have to go to the right folder to run the function. So what I'd ideally want to happen is that this function is just running all the time. So whenever I download something, this program is just always running. I haven't figured out how to do that, but what I have figured out how to do, well, in my root folder, which opens whenever I open a new terminal window, I have this automate.sh file, which essentially all this does is, if you look at what's actually in this, it bundles these two commands of going into the folder where this program exists and then running the program into this one file that you can just run using one command. The first project we're going to be building is an image editor. Now you might think that in order to edit great looking photos, you need something like Photoshop. Think again, because all you actually need is Python. Let me show you how. There's this really great library in Python. It is this one, and I'll leave the documentation down below in the description so you can like figure out what else to do besides the things that I'm gonna teach you how to do. Essentially the way you install it is with this command, and we're just gonna copy that. I already have it installed, so it's not gonna like do it for me, but essentially that is how you install it. We're gonna start with some imports. Then we're gonna define a folder to which we are going to add some photos that we want to edit, and we're also going to define a folder where we want the edited photos to go once they are edited. We're going to define these as variables just like that. So let's say I have some sexy images of myself which I want to edit to look a bit better. Essentially, if I want to make a new Instagram post out of these, I might want to edit them a bit. Usually I would do this in like Photoshop. If you're using Python, it's going to be much easier and much faster, as you will see. And now to access all of these photos, the magic of Python is that you can apply all of the same edits to all of the photos in this folder automatically. And to do that, we're going to apply some magic. Just kidding, just some Python code. For file name in os.list_dir with path. So essentially all this piece of code does is access all of these files, all of these images in this folder, and I'll apply all the code which we're going to write to it. First, to open this image using this library, we're going to go image.open, and we're going to do this. This is an F string to make sure we accident the whole file. You can just copy this exact one. Essentially now this variable holds this image object, which is going to allow us to do some edits to it. For example, what we can do is sharpen it. We're going to go edit equals image dot, and I need to filter, and inside we're going to go image filter dot sharpen. We're gonna need to do a bit of trickery. Essentially, we need to clean out the name, edit dot save, and I had this saved, and I'm gonna do like that. And essentially, this thing is going to apply some edits to all of these photos and save the edited images in this edited image folder. You ready? We go Python 3 photo editor.py. And now we have sharpened versions of these images. It's probably not very clear, and for some reason it rotates them to the left. So actually what we need to do is to this one, we need to do dot, I believe it's convert and a capital L inside. I don't just know this by heart. I learned this by looking at the documentation, and the things that I'm doing here are just examples that you can do. By going into the documentation, you can find a bunch of other types of edits that you might want to do. This is just examples. So if you do that, well, actually, no, I forgot. To convert to L is actually the way you convert it to grayscale. I actually kind of like that, so we'll leave that. The way you did rotation was by doing, well, rotate, not convert. And we're gonna go, I believe you do -90 in this instance. And now they are the right way around, and they are also black and white. Then you could obviously do a lot of other things. What I like to do to my images is increase the contrast. What you would do is define a factor to be 1.5, for example. Answer equals image enhance dot contrast, which just creates this object again with like contrast editing capabilities or something like that. And inside we put the edit, and now we have this enhancer object, and this we're going to go edit equals enhancer dot enhance with this factor that we defined. And now this new image should have some more contrast. We're going to see if this works. If you open these, you can see that these are a lot more contrasty. And basically what you could do, if these are the exact edits that you would want to do to all of your photos which you're posting on Instagram, for example, what you can just do is copy them to this one folder, just run this program, and automatically everything is going to be applied. You don't need to like manually edit every photo anymore ever again. Pretty cool. Let's move on to the next project. This next one is a YouTube video downloader. Now let's say you're going on a trip, for example, you're going on a road trip, or you're going on a flight where you're not going to have access to internet, yet you still want to be able to watch internet made coder videos while you're on your trip, or maybe some other YouTubers, I guess. How do you solve this problem? Well, what you could do is sign up to YouTube Premium and pay YouTube like, I don't know, what is like $10 a month to be able to download videos to your computer. Or you can code like 15 lines of Python code and simply download all the videos that you want to download to your computer for completely free. And I'm going to show you how to do that. What we're going to do is, again, we're going to be using a Python library. The library we're going to be using here is called PyTube. We're going to copy, install PyTube like this. I already have it. And from PyTube, we're going to import YouTube. I believe it's actually YouTube, like that. Then we're going to go from sys import arg. So the way I want to be able to run this program is just from the command line. I want to be able to run this program name as well as the link to the YouTube video which I want to download. The way we're going to be able to access the link from the command line in our Python code is using this argv built-in library. What this means is that essentially argv takes all of the things that you input into the command line when you're running this program. Essentially, the first argument is always going to be the program name. So that's why we don't want to access this one, because this will just output the name of this program. argv1 is going to be the first command line argument which we give when we run this program. So that is how we're going to be able to access it. And then we're going to need to create this YouTube object from yt equals YouTube. And I believe I need to put this link inside of it. So it's going to be create this YouTube object from this link. And basically, first, let's just try to print some information about this YouTube video which we want to download. For example, we want to print the title of the video just to see that it works properly. Title equals, and we could go yt.title like this. Like this, right? Yeah. And then we might also want to print the number of views that that video has right now. Views, colon, and the way we access that is just yt.views, I believe. Yep, seems to work. And let's just see what happens. So we're gonna go Python 3 yt downloader, and I believe I need to put this in quotation marks just like this. And just like that, it works. It shows title of the video as well as the current views of that video. Pretty cool. Okay, so now if we want to download this video, what do we actually do? Well, it's very simple. It's actually only 2 lines of code. Let's say we're gonna just define a variable called yt equal to yt.streams.get highest resolution. Essentially what this does is, because there's obviously multiple different streams of the video that you can download. You can download the 4K version, or you can download the 360p version if you've got potato internet. Essentially this function here ensures that it's going to download the highest version of the video possible. So in this case, I believe there's a 4K version. There should be a 4K version available of that video. And then we just go yt.download and then we need to input the folder to which we want to download this video. Usually use this program myself when I'm editing these YouTube videos and I want to include some clips from either my own YouTube videos or some other YouTube videos, and I usually like to put them inside this kind of folder right here. And you're obviously just gonna input whatever folder you want your videos to go to, and then we're gonna see if this works. It's gonna download, and you see that it's sort of waiting. It's waiting for the video to download, and looks like nothing went wrong. Now we're gonna go into this folder on my computer right here. It's right here, YouTube downloads, and would you look at that, it's right there. This video is now downloaded into my computer. Pretty cool again. Let's move on to the next one. By the way, at this point, if you're finding this video useful, a like on this video down below in the description would be highly helpful, because it shows YouTube that this video is actually half decent, and it actually makes the YouTube algorithm show this video to more people. So if you could just take 2 seconds to go down there and like the video, I would be highly appreciative of that. And as a reward for doing that, here's a picture of a cute cat. Okay, now to the last project, which is also very exciting. What we're going to be doing is a simple PDF merger. So, for example, when I was in university, a lot of the times I needed to combine multiple PDFs into a single file. And the way I would do it is that there's a lot of these web-based PDF mergers where I needed to upload my PDFs into this website, and it would like take some time to like merge them and then output this new file. But now, whenever I need to do it, I just use my own Python script, which took me like 5 minutes to code, and it's much easier, especially when at the end of the video I show how to actually run all of these just from your terminal window using shell scripting. But first, let's code this up in Python. What we're gonna need to install here is another library. This time it's called, I believe it's PyPDF2. That's the one. And we're gonna import it from import PyPDF2. Then we're gonna import sys, and let's start coding. Now over here, I've got these 2 pretty disgusting looking PDFs from my university days. Oh God, I'm so glad I never have to read stuff like this again. But essentially, let's say I'm still an economics student at university. I need to combine these 2 files into one file to upload it as an assignment or whatever. For file in OS list dir, and we're gonna import OS as well. And the way we're gonna access the current directory is by going os.cur.dir, like this, and we're just gonna print file to see that it's working. Actually not like this, obviously like this. And then obviously we need to check that the file is actually a PDF, so that if file ends with .pdf, then we want to access the file and do some magic to it. And just like that, we can see that it is indeed working, and now we can just merge them. Essentially, the way we do it is we create this merger object by going pypdf2.pdf file merger right there, and inside we don't need to put anything. This creates this merger object, which we can now do some magic to merge these files. And all we do is 2 lines of code. We go merger append file, not style, file, just like that. And then we need to write these into one combined file that actually saves it as. We go merger, I believe it's bright, and we just need to give it a name. And the name we're gonna give it to is combined bs uni docs.pdf, just like this. And let's see if this works. Let's see if I made any mistakes. I made mistakes. Let's see what mistakes I made. Yeah, we want to define this before we do any of this other stuff. We want to define this object right here, up here. Okay, it does look like it worked. And yeah, again, I will leave the documentation to this library in the description if you want to do other stuff with PDFs. But this is just a very basic, it's 10 lines of code. And you can just do the same thing that would have taken at least a couple of minutes before. Pretty amazing. Now, what I'm going to show you is how you can make this even faster. So normally to run the script, you need to go to your terminal window and then CD into the appropriate folder where all of these programs reside, which would take some time, obviously, if you want to run this multiple times. But what you can do instead is code something called a shell script, which you can just basically run from this command line window, which opens up every time you open your terminal window. Essentially, for example, for my YouTube thing, is I can just go tsh youtube.sh and then give the link, and it's just gonna download it. And the way you do that is pretty easy. You're going to create a new .sh file, which is basically a file which you can run using your shell script directly from your command. You just do exactly what I do. What we're going to do is go nano, which is this command line based text editor, and we're just going to give it a name yt.sh, and the sh ending is really important here. We go enter. We're going to create this file. And basically here all you do is you go cd and then you copy the folder where your file resides. The way you get this is you go to where you would normally run your Python code in your WD, which stands for present working directory, and you get the present working directory, you copy it. So basically what we're doing is once this file runs, the first thing it's going to do is going to cd, so change into the correct directory, and then it's simply going to run the file. We're going to go Python 3, and actually I almost forgot a very important part. At the start of these shell files, what you need to always include is this line, which is like hashtag !bin/sh. It essentially tells the program what version of the shell or what program it needs to use to run this. Basically, you don't need to know any of that. Just include this line at the top of all your shell scripts. Then you do this, and you remember how for the YouTube program we needed a command line argument. The program needed to access the link of your YouTube video as a command line argument. The way we do the same thing as a shell script is much easier. You just go $1. Essentially, that's all you need to do. What this is going to do is once you input a command line argument on your terminal window, it's going to access it using this $1 thing, and it's going to know that that is actually the link that it needs to then feed into your Python program, which will then do all the magic which we did before. We go and save this, we go Control X, it's going to ask you if you want to save, you're going to Y, enter, then now this is where the real magic happens. You go GSH, the name of our file, oyt.sh, quotation marks, link, quotation mark, boom, it shows the title, it shows the view, it's downloading it, let's see if it works. We go in our folder, and would you look at that, it's right there. Pretty magical. And basically you can do this exact same thing for all your other files as well. You could go nano.pdf.sh, and you're just gonna go and basically do the same things, and I'll leave that to you as an exercise to do. So if you want to learn to code, you're probably someone who's quite motivated and you generally want to be on top of things, so you probably want to follow the news, right? But because coding takes so much time, you might not have the time to always open up the 5 different news sources that you use to get your news and read all the main headlines. So that is why with our first project we're building a news automator. There is this really cool API called News API. And what I'm talking about is this one right here. You're gonna click on this button here, get API key. Then you're going to go to your code file. At the top, you're going to create a variable like this. We use API underscore key equals, and then you're gonna paste basically the key that you get from your API. I've got my actual API key just above here, but I'm not gonna show it to you because it's private. Then we're gonna start defining some functions. First of all, we want to create this object of query parameters. If you send a network request to this URL right here, it's going to call the API, and based on the parameters that you give it, it's going to send you some response. And to show you what that means is if you go to the documentation of the News API, to get top articles, to send a request to this URL right here, which we have already defined up here. For example, for country, we can just define it in our object as country, colon, and then there's a list of all options. And then for category, for example, here we can see that the category can be one of either business, entertainment, general, or basically one of these. And then the different ones that you can set, like for example, keyword to search the news articles for. So once we set the parameters that we actually want, so for this first one, we're just going to define a function to search news by category. We're going to define this other function that we're going to pass these parameters to. And here, the way we actually make a network request to this API using Python is using this requests library. So we go requests.get with the parameters that we just defined and pass to the function. Example response that you're going to get that's going to be sent to your code is going to be something like this. And the way we actually access that with our code is by calling response.json. And then we are essentially going to have this object for us to manipulate. And if you just look at it, we can see that we need to find the articles key, which is then going to give us a list of all the articles with all these fields. And we're going to define an empty array of results and for article in articles. So it's going to be a for loop, loops over all the articles. We're going to append an object to this results array that has the title, which we're gonna get with the title key from the article object and the URL field. And the way I know that this is how it's formatted is, again, just by looking at this example response. We can see that for every article object, we have a title, we have an author, we have a source. And then at the end, for all of the results, we are going to print a title and the URL as well as a new line. And to see how that works, I put this Python script inside of my path in such a way that all I have to do is from my terminal window, I'm going to just go news and then the name of the category, which is business, for example, and then it's going to print the top business articles from all the news sources for the country that I've chosen, which is the UK. And the way I did this is by going into my Finder, going into your root folder, and then to get hidden files to show up, you have to go, I believe it's Command, Shift, and period, and you should find a file called .z profile if you're on a Mac. And in here, you're going to define alias and whatever you want to call the program. You're going to go, for example, news equals Python, and then the path to the actual script. And then what that is going to do is whenever on the terminal window you type news, it is going to be aliased to this command. So essentially it's, instead of running news, it's going to run whatever you defined here. So Python and then the script, if that makes sense. And then if we look back at our script, the way I've defined it is that argv1, which you import from sys, argv1 is going to get the first command line argument. You can obviously do whatever you want with this. That's just how I've defined it for myself. And you probably saw that I've defined some other functions as well. For example, I've defined this function that instead of getting articles by category, it gets my query. And again, I just looked at the API documentation, q:, the query string that we want to search for. And then if we run that function right here, for example, comment these out for a minute, is now going to get me articles from the UK that match the keyword of Liz Truss, who is the current Prime Minister of the UK, who's doing a very terrible job. These are just some examples of how you might use this particular API. You can define all sorts of functions, for example, to search for articles by country, a ton of different things you can do to automate news for you. With that, I think that's pretty cool and something that I actually might see myself using from now on. With that, let's move on to the next script, which is probably the coolest Python script that I have made so far, honestly. And I'm so excited to share this. What we're talking about here is a eBay price tracker. Essentially, let's say you want to buy something on eBay. For example, I want to buy an M1 MacBook Air, and I'm just looking to buy one used, right? It can be difficult to tell what is a good price to pay for a used item, because as you can see, there's all sorts of different prices that these M1 MacBooks are being listed for. And obviously, to actually figure it out, you would need to do something like come here a couple of times, look at all the different prices and sort of take an average. And then once you see something that's below the average, that's when you know that it's a good deal. But actually doing something like this manually can take a while. So why don't we make a Python script that does it all for you using something called web scraping. A web page like this, it sort of has a couple of different things going on. At the end of the day, a lot of these things that you see over here, like the way they're laid out, the way they look, all these images, all of this is like just styling. But behind the scenes, if you look at the source of a web page, all we really have here in terms of the content, so the content that we actually care about, is a nested list of HTML. So like different HTML elements, all with different information in them. We can use Python to essentially load up this information, so without the styling, because the Python code doesn't care about what the web page looks like, and then search for things using these tags that we can see here. And the way we do that is we need to install something called Beautiful Soup, and then you also wanna install and import these other packages. Just in a moment we'll see what we actually use this for. Then you're going to go on eBay, and I'm on the eBay UK side because I'm in the UK, but whatever country site you use, you're gonna go there, you're gonna search for whatever you actually want to track the price of. Then you're gonna copy the link up here and you're gonna paste it as a link variable right here. Then we're gonna define a function. This is gonna take a link, and at the end here, we run it with the link that we defined. We send a get request to get this page using a Python code. Then in order to actually look at it, we are going to use Beautiful Soup. So we're gonna go page underscore path equals Beautiful Soup. with r.text as the first variable and then HTML parser as the second parameter. And just right here, if you just quickly print this page parse just to see what's actually going on here. When you strip out all the styling, all the JavaScript, all of that, this is actually what this web page is like. If you just care about the content, like the actual information, this is obviously a lot to look at. What we instead want to do is go to the actual eBay page, and what we're looking for here, all of these search items in this UL, so unordered list, and all of them have this list object that have a class of s-item. So what we can do with Beautiful Soup is have a variable called search results by going page parse.find, and we're going to find a UL that has a class of SRP results, and from that UL we want to find all items that are inside an LI tag that have a class of s-item. So essentially this is going to create a list of all of these list items that have all of our search result that we want to look at. Then we're going to define an empty array of item prices, and for all of these search results we are going to then find the actual price. And again, we just look at the page element in here, we go on top of the price and see that it is indeed inside a span that has a class of s-item underscore price. And to actually get this from over here, from all of these, we would look for a span that has a class of s-item underscore price. And to get it as text, we go .text. And then sometimes in this search result, I actually see, okay, I don't think we have that now, but basically I just found when I was trying this that sometimes we would get like price to some other price. So just to avoid that, we go if 2 is in that price text, we just ignore it basically. But if it's not, get the actual price, because right now we're just literally gonna get a string with this pound sign, and then if it's more than 1,000, it's gonna have a comment, just to make sure that we're only getting the number, price as text from item index 1 to ignore the pound sign, and we replace a comma with nothing in case it's more than 1,000 and it has a comma. So essentially that just passes it as a number, and then we return them. So if we just do that, it's all already going to work. There's a couple of other things I did after this which we can look at. If we just run this right now and we print them, and look, would you look at that, we have a list of the prices of all of the MacBooks in our search result right here. But we're not done yet. Just to remove some outliers, basically I've created this function here, which is going to use NumPy to essentially edit our list of prices in such a way that if the price is either 2 standard deviations below or 2 standard deviations above the mean of our prices, then we're going to ignore it. And the last thing we're actually doing, first of all, defining a separate function to get the average if you want, and we can even print that here. But to actually make this project as useful as possible, it might be worth actually tracking the price over a couple of different days and then sort of getting the average of those. To do that, we're going to define this very last function over here, which basically just saves all of these prices in a CSV file with the date. And again, the specifics of this function here don't matter that much. You can literally just copy this, I don't care. Basically creates this prices.csv file, which is going to have a field for the date and then the average price. And again, this is literally a program that I probably will be using going forward. So on to the last one. We're gonna be making a Python voice recognition bot. Exciting times. And the way we do that, first of all, we need to pip install speech recognition. I've just got this random text file over here.
Hello world, this is a test file for my Python script.
You're gonna go test file name equals the file name of the audio file. I think it needs to be in this format, or I think MP4 works as well. Then we're going to go r equals sr.recognizer, which is gonna initialize an instance of a class that can recognize speech. Then we're going to define this function over here, which is going to take a file name. And the first one is very easy. All we have to do is with sr.audio file, taking the file name as source, we go audio underscore data equals r.record, which is going to record the audio from the audio file into this variable. Then we transcribe it into text by going r.recognize underscore Google, which is going to use like the Google speech recognition API software, something like that, taking in the audio data that we just saved up above, and then return the test. So if we print that, would you look at that? If that's magical to you, go hit the like button. To make this even better, we want to be able to record our voice from our microphone and immediately transcribe it into text. And for this, it's actually slightly more complicated, but not that complicated. Go pip install sound device. We're also going to import these two things right here. And define this other function. Basically here you might need to do some tweaking because this is going to slightly depend on your audio device. Basically, you're going to define a variable called sample rate, which for most devices, I believe is going to be 44,100. Duration is going to tell a program how many seconds to record audio for. Then we go to audio recording equals sd.rec. Duration times our sample rate equals sample rate, channels equals, for me it's 1, for some devices it's 2. Again, I'm not an audio expert, this just sort of depends on your audio device. And then dtype, something called int32. And print recording audio, sd.wait, which is gonna wait for you to record audio. Actually, let me just run this through just to show you actually what it is doing here. It's going to start recording right now. This is now being recorded by my microphone. It's gonna do it for 5 seconds. Right now, this is now being recorded by my microphone. But to do actually what we want to do, what we then want to do is write this into a text file. And very simply to do that, we just go wab.write. We're going to define a name for the file that we want to write. And this is one of these other variables that we've got saved up here. We're just going to save it as recording.wab with the sample rate and audio recordings or the data that we just recorded. This is going to store it into a WAV, so a sound file. So not quite what we want here, but essentially once you run this, you're going to get this file to pop up right here with the name that you just defined above. And then what we want to do is pass this file into yet another function. So we're going to go save text to file, and we're going to take the new file name of the file that we want to save our text to, which again, we're going to go up here and save a third file name variable. For me, I'm just going to voice as text.txt, and then all we go with open file name. And it's important that you choose the parameter of W to tell the program that you're going to be writing to the file rather than just reading it as F or file or whatever, f.write, and we write the text that we pass in the function into this file. And then at the bottom, when we run all of these chains together, what we are doing, first we're going to run the function to recognize voice from a microphone, which is going to give us this recording sound file over here, or it's going to overwrite it if you already have it. Then we're going to pass that file into our recognize from file function. That is going to return that file as text, and we're going to save that as text from voice. And then we're going to pass this text from voice into the save text from file function, which is going to simply save this text variable as a file with the file name that we defined above. If this chain of events doesn't make sense to you, just pause the video. I promise you this should make sense. And if you run it, we're gonna see some absolute magic. First of all, it's going to record. This is a recording. Please subscribe to my channel. It's the best YouTube channel ever. This is a recording. Please subscribe to my channel. It's the best YouTube channel. And now, if we open our voices text.txt, are you ready for this? Boom. Please subscribe to my YouTube channel. It's best. Okay, I messed up the recording a bit, but you get the point. The first thing we need to do is connect to the Google Calendar API. So let's see if I still remember how to do this. So first you need to create a project in the Google Cloud Console. Then you need to go to the left-hand side here, click APIs and Services, enable APIs and Services, then search for Google Calendar. You're going to click on Google Calendar API and click Enable. The next thing you need to do is go to OAuth consent screen on the left. The only option you'll have is external, so you're going to click that and create. Then give your app a name, select your email as a user support email. Then you're going to scroll all the way down here and again input your email. Click on add or remove scopes, and then essentially just scroll down, find all the ones related to Google Calendar. I have no idea what all of these do, but I'm just selecting all of them just to be safe. Then you're going to go down, click save and continue, then continue again. Then you're going to go to credentials, click create credentials and OAuth client ID. As application type, I'm just going to put desktop application. Then click on create, and you're going to click on download JSON. What you need to do with this file is you need to move it to the same folder where you're going to be writing your code and rename it to credentials.json. After that, you can copy this quick start code from this link, which I'm going to leave down below. Before we do this, the only change we'll make is in the scopes, remove the .read only, because what we want to do is give ourselves the ability to actually modify our calendar and not just read it. We should ask for our permission to allow ourselves to access our own app. And that was not supposed to happen. Okay, I figured out what was wrong. In order to fix this error, what we need to do is go down here back to our console, and we're gonna find add test users. So we're gonna add ourselves as a test user for this app to allow ourselves to use our own app. And now when we do this, we can just click on continue and then authorize ourselves to be a user of our app. And voila, we are now connected to the Google Cloud API. If you have some items in your calendar, it should retrieve 10 items from your calendar and show them to you. As you can see, the only events I've placed in my calendar is to meet my friend Conrad, apparently. So now we can get into some Python magic business. Starting from the main function, what all of this does simply connects you to the API, so we don't need to worry about that. So starting this line 35, we're actually going to wrap this into a function. Now this line is going to connect with the API, and instead of getting the upcoming 10 events, what we want to do is essentially save all of the past events from this day into a database. To get the day, we're going to change this a little bit. We're going to go get today's date using datetime.date.today, and basically these lines just give you the time and day from the start of the day in the correct format till the end of the day in the correct format. It's just the format that you need to use with Google Calendar API. You don't need to worry about it. And now for this one, what you need to change is this calendar ID. What you need to do is go to your Google Calendar, and when you go into the settings, you're going to find this ID for the current calendar. For example, for me, I have several calendars. For example, for my programming hours, I have one calendar, and I've set up another calendar to track my YouTube hours, for example. And you're going to copy it here. This primary is essentially just going to use your default one. So if you use your default one, you can leave this as primary. We're going to copy this down there. So this whole line is going to be getting events from your calendar. And you want to set up the start time and the end time for the window from which it's going to be grabbing these events. So that's why we've set up this time min to be this time start variable, which we defined before, the time max to be this time end that we defined before. Then you just set single events true, what about start time and time zone, whatever time zone you have, and then dot execute, which is going to save these events in this events result variable. Then we're going to go events underscore results dot get. If there's nothing there, I'm going to go print no upcoming events found. Now the first thing that we want to be doing is adding up the duration of all the hours that we find based on our API call. It's going to be a little bit complicated because when we get the time from the API, it's going to be in this weird ISO time format. We're going to set it to datetime.time delta, which creates the time delta class for seconds, minutes, hours, zero. Why it's like this is going to become clear in a second. Print coding hours, then for event in events. Basically, now we first need to get the duration of an event. We need to do a bit of trickery, but it's all good. What we're gonna do is use these lines. So the start of the event is gonna be event.start.get, and basically this kind of stuff. Essentially how I found this is on Stack Overflow. So these two are gonna get the start and end time of your event. And what we still need to do is reformat it into this specific format that we want. And for this, we also need to import from dateutil this parser function. Actually, better names for this would probably be something like start formatted and end formatted. And the duration is simply gonna be end formatted minus start formatted. Now we have the duration of the event and we're gonna add it to our sum. This we can simply do by going to the duration plus equals duration. And then we're just going to print on the command line summary of the event and the duration. And at the end of all of this, we're going to print total coding time with the total duration. And we're going to remove these default lines right here because we're not going to need that anymore. And we've just got this error handler here automatically as well. And now lastly, of course, in our main function up here, we're going to just make sure we run our function commit hours with creds inside. When we run this, I've set up some test events on my own calendar, so they should show up. And as you can see, it grabs these two events, which I've got on my Google Calendar, and shows the total time as the sum of all of this. Now, next thing, we're going to set up an SQL database to save these hours into so that we can grab them later in later dates and compare where our time is going to over time. And obviously at this point, we're just doing this for my programming hours. If you want to track your time watching anime, I won't judge you. So first we're gonna go and import SQLite. And next it is time to learn how to use SQL. Then I've actually defined this other file where we essentially create the table where these hours are gonna be saved. This one you just need to run once. So first we're gonna create the actual file and connect to it using these lines up here. Then we're gonna go con.execute, and whenever you run SQL commands using Python, you need to start it using 3 of these single double quotation marks, then create table and the name of the table, and then all the columns of the table that you want. So we want a date, which is going to be of type date, not null, category, which is text, and hours, which is an integer. And again, if all of this is confusing to you, go do some courses from learnersql.com. Basically, you just run this once to initialize the table, and then we can continue on with our main file. We're again going to get today's day by going datetime.day.today. We first need to format our time a little bit. We're going to go format the total duration equals total underscore duration dot seconds, which is going to get all the time in seconds, and then divided by 60, which is going to get it in hours. This is so that we can actually input it as an actual number into a database rather than this weird Google Calendar API time format. Coding underscore hours equals tuple of date, the name of coding. This is just sort of in the table I can separate what are coding hours and what are YouTube hours and whatever else I want to add to it in the future. So that's a category, and then formatted total duration as the time. And to execute this cur.execute, and then these lines insert into table name, values, and this is gonna look a bit weird. Essentially what this does is these question marks, which is the values that are gonna be inserted into the table, are gonna be replaced by this tuple that we created up above here. And after that, all you have to do is on.commit. You're gonna commit our changes into the table, and after you run this, if there's no errors, you should find this hours.db file on your left. And if you're on VS Code, in order to actually view this, you're gonna have to install this SQLite viewer extension. And with any other text editor, you can probably Google how to view these database files on your coding editors. But as you can see in here, I've already got some hours from my previous days. And once you run this file, what should happen is that my today's hours are added into the database. So we're going to try that. You can see coding hours added to the database successfully, and when we refresh this, we can actually see that today's hours, which is 9th of August, are successfully in the database. First step of our program done. Wasn't too bad, was it? Give yourself a pat on the back and let's keep going. The next thing we want to do is be able to create an event just from our command line, just from our Python program, rather than having to open up Google Calendar, create a new event, and do all of that, which just takes a lot of time essentially. We're going to create another function called add event, and inside of there, we're going to have to pass a couple of things. First a creds, then a duration that we want to give to our event, and a description to the event. For now, this is just going to be arguments to the function, but at the end of the video, I'm going to show you how to do this directly from the command line using shell scripting. Again, we're going to do some stuff with the time. Essentially, you just go datetime.utc now. A couple of more lines, but essentially what we're doing here is creating an event from the current time up until however many hours we define as the duration. So the end time is going to be datetime.datetime start plus a datetime.time delta, which creates this delta, so essentially a difference from the current time into the end time. And the way we just do this is using this line right here, and inside the hours we're going to define as a duration. And then again, we're going to need to do some formatting. Format is going to be start.iso format plus this Z letter, which I don't know exactly how this works, but essentially this is again just a format that the Google Calendar API wants. Then we're going to need to define this event variable right here. Essentially this here is going to define what our event is going to be. You know, on Google Calendar, when you go to manually add an event using the GUI, it's going to give you a lot of options to give you like notifications about it, the description, the time, the name, the category, all of that. And using code, the way we define this is using this object right here. And I've just got the bare bones of the things that I actually want to put inside the event. If you want to put more information than this, you can go do the Google Calendar API documentation down below, and it's going to show you all the options that you can give to your event. But essentially all I need is the summary, which is the description variable, which we've defined as an argument of the function, start day, which is going to be in this kind of weird format again, where the datetime is the start formatted, which we just created. Time zone, again, my time zone, which is in London in the UK. And then end is going to be this end formatted variable, which we just created. Then we're going to go service equals, very similar thing to we did in the past. Then to actually insert this event into the calendar, we're going to go service.events insert. This is the key function right here. Again, the calendar ID, you're going to select the same calendar ID you want to add it to, and then the body equals this event variable that we defined. And then simply .execute, which is actually going to place this event into your Google Calendar, which is going to be pretty exciting. And then at the end, you're just going to print event created to show yourself that it was created successfully. Now we're just going to define all these variables. Let's say a duration of 2 hours and a description of hello YouTube. And once we run this, it should actually arrive in my calendar. And of course there's an error. Okay, I figured it out. What we need to do instead is in here as well, just go datetime.utc now and then add this time delta to get the end. Now when we run this, it should work. And as you can see, the Hello YouTube event is in our Google Calendar straight from our Python code. Isn't that amazing? If you're finding that amazing, leave a like down below. Now we're almost done. What we now just need to do is be able to do this from our command line. First, we need ways to run either this commit hours function or the add event function, not both. We first need to import from sys argv. If you're not familiar with argv is essentially just allows you to access command line arguments that you pass your Python function from the command line. And here we're gonna go if argv1, so argv0 is always just gonna be your program name. Argv1 equals, let's say if we give it the argument of add, then what we want to do is run this add event function. Whereas if the first argument is, let's say, commit, then we want to run the commit hours function. And obviously for the add, we would need to be able to get the parameters of the function from the command line. So let's say the first argument is going to be the duration, the second is going to be the description. We're going to set duration as argv2 and the description as argv3. And then to the function, all we're going to do is pass in the duration and the description that we got. For the commit, we basically don't need to do any of that. The idea how I'm going to be using this is that whenever I start working, I run this add function to add an event for however many hours of deep work I want to do in that moment. And then at the end of the day, I just run this commit function to commit all the hours of the day into the database. So I'm going to do by add, let's say a 3-hour event, and it doesn't work because for some reason it's taking it in as a string rather than an integer. So we're just gonna go back into the add event function and make this duration forced into an integer. And now let's see if it works. Seems to have worked. The last thing we're gonna do is essentially gonna be creating an alias to run this program from this directory with just one command. Open up your Finder and click Command Shift period to show your hidden files. Exciting, right? If you're on Mac, you're gonna find this .z profile file. You can open it, and in here you can create these aliases. Go alias, and then let's say time manager equals. Then we're gonna grab present working directory. We're gonna set it here like this, and the name of the file. Essentially, this is just an alias for this full path of the program. Okay, so to make this work, you have to restart your terminal window. It looks like in order to make this work, what I also had to do is copy the credential.json file into the root directory, which opens up when you open a new terminal window. With that, as you do it, it's gonna ask you to authorize again. And once you do that, you can create events in your calendar and run this whole thing just from your terminal window without having to actually open up your Python file. Now the last thing is a function which I've done for myself, which is this get hours function, which allows you to, as I said, get all the hours and show them to you. Now this one I will actually leave to you as an exercise. As I always say, the best way to learn to code is to do stuff yourself. And I believe with this background knowledge that I've done in the past, using it, Googling it, using Stack Overflow, Google Calendar API documentation, you should be able to figure out how to do this. The goal of our program is that you can run your program again, just with some keyword, then define how many days you want to get the hours from. We're gonna say 5, for example, and it's going to show you all your hours from these days, as well as calculate the total and calculate the average and print them all to you. I am going to leave my code for this specific function down below in the description, which you can look at as a solution or as inspiration if you do get stuck. Do definitely try to do this yourself first. If this was helpful to you, you're welcome to use exactly what I did, but what I obviously recommend you do is figure out how to apply this for your specific needs. As I always say, most exciting thing about coding is building stuff that's useful for you and allows you to do things, automate things that you do anyway, just optimize your life essentially. For more Python tutorials like this, I made these 2 videos up here. They've been extremely popular on my channel, so I think you'll really enjoy them. Also, if you enjoyed this video, I highly recommend you subscribe to the channel. I'm on a mission to make the best coding videos on the internet. We're gonna hit 1 million subscribers. Go join the movement down below. With that, let's all keep coding and enjoying the journey along the way. I will see you next time. The first thing we'll be looking at is being able to use Python to read and manipulate CSV files. taking in data and having the skill of being able to read and manipulate it using Python was one of the most common things I was doing, and one of the most common skills that you will need to have in your arsenal as a developer. Basically in Python, you will have access to a library called CSV, which you can import using the normal import statement using Python. And for this example, we're writing a simple finance manager where I'm basically taking a CSV file of transactions, which I've got right here. And then the goal is to extract the information that we actually care about, like for example, the date, the name and the amount of the transactions, not have to deal with all of these things like transaction IDs and a lot of this other stuff that we really don't care about. What we're going to do is define this function called finance manager, which is simply going to take in a file name. We're going to start off with a sum that's initialized to 0, because what we're going to want to do is to actually sum the transactions from the entire month. And then the crucial function that we need to use is provide with open with the file, and then mode is going to be R, which means read. So we only want to be reading the file rather than writing it. If we wanted to write something into the file, you would use W, but here we're going to go R, and then as CSV file. And we're going to initialize a variable called CSV reader by calling CSV.reader and the CSV file inside of it, and we're gonna give the CSV file as a parameter. Now the CSV reader is basically a reader that allows us to read this file and do a bunch of things to it from the CSV library. So this is what we're gonna be using most of the time. We're gonna skip the header by calling it next, because basically in this file we have this header file that we don't actually want, because this is not an actual transaction. We're just sort of storing it here, even though we're not going to use it, because we just want to skip over it, so that when we start looping over these rows using this for loop over here, we're not going to be going over the header file at all. Then what I want, you might be interested in some other information. I just want the name and the amount and the currency, and then I'm going to go to the file and look at which of these columns are the things that we want. So it's going to be index number 1, index number 2, 3, 4, and index number 5, 6, 7, I believe. Then we're going to create this transaction tuple using these variables that we just got from the file, and we're going to add to the sum the amount of the transaction, and then to this transactions list, which should probably actually be defined somewhere in here. We initialize, we're gonna just append the transaction itself, and at the end we're gonna print the sum of all the transactions is whatever it is. We're gonna print an empty line, and then we're gonna return the transaction, and at the end we're gonna try running this. Basically this is just an F string. Don't worry if you're not familiar with this, you could literally just go monzo and then just input the file like this, and when we run this, we should get the sum of the transactions was this much, and these are all the transactions we had. If you're interested in doing something with CSVs, I will leave all of this code down below that you can use as a starting point, and then based on what you want to create, based on what's interesting to you, you can use these same concepts to do a lot more things. For example, the startup that I'm building right now is a personal finance app where I'm essentially using a lot of these same functions, a lot of these same tools to take in CSV transactions from the users and then send that data in the format that I want based on my app to allow me to then visualize it for the user in different kinds of ways. So that's just an example of a real world use case for these skills. With that, let's move on to the next one. So project number 2 is a desktop cleaner. Basically, if you've ever been in a situation where your desktop looks like this, then this is going to be an interesting project for you. I've defined several different paths to different folders based on the type of file that I want to be sent to these different folders. I've defined a source directory, which is going to be in my downloads folder. This could be your desktop or whatever. And then I've defined these lists, which I'm going to leave down below in the code section, for different file extensions based on the file type. So we know that every file type that has one of these extensions is going to be an image. Every one that has one of these extensions is going to be a video. And then we have this onCleaner function, which is the main function. This function is going to run, and then with scander with the source directory as entries, this function in here, which we have imported from the OS library in Python, is going to actually take every file in this directory, and it's going to return it to you as a list. And then we're going to loop through that list with a for loop, get the name using entry.name, and you would find how to do this in the documentation and everything like that. And then we're going to run this function called check audio, check video, check image files, and check document files. And all of these are basically functions to check whether that file is a video or an audio or an image or a document file. For example, for this one, it's going to loop through all the extensions in the video extensions list. It's going to check whether the name ends with that extension to determine whether it's a video file or not. And if it is, it's going to run this move file function, which is going to move that file into the video destination folder, which we have simply defined for us right there. And the move file function simply looks like this. First, it's going to check whether that file already exists. If it does, it's gonna do this function to like make the name unique and a bunch of stuff that's like not that important. And then after that, it's going to run the move function, which is simply a function that is imported from this shuttle library. That is how that project works. And then I have a more complicated version of this that I actually use in my literally everyday life. There's a full tutorial on that on my channel, but basically you can expand this to have this be running automatically at all times, and then automatically whenever something goes into my downloads folder, it's gonna run this and it's gonna move into the correct folder. It's pretty cool once you learn to do this. I actually had this on my GitHub and it's become sort of an open source project. A lot of you have been helping me with this. Just bear in mind, if you watch the tutorial, it's a pretty old video, so the version I have there is not quite as optimal as it could be. With that, let us move on to project 3. An email sender. This is also going to introduce us to APIs, and the API that I use to send emails is something called Mailgun. I'll just go on here. You get, I believe, 5,000 emails a month for free. You would go and click on get started for free, and then you will get an account. And the easiest way for you to get started, you go on sending an overview, then click select API. You're gonna get this starter code, like you'd literally just copy it, and this is essentially going to allow you to use it, but I just did it my way. You copy this line from here as a variable inside your program, and then you'll find your API key, which you can get by clicking on API keys on here, and you would copy from here. And then I believe you need to go and add yourself as a verified user for basically to allow you to send yourself emails. And you would do that by clicking on here and just entering your email address and then saving it. By the way, with your API key, make sure to never show it to anyone, because these are private, and definitely never broadcast it to tens of thousands of people online. Anyway, this would be my API key right here. Then we would define the function called send email, takes in the to email, the subject and the body, which we define down here, and then we run the function with those. In here we created this data object, and you'll find how to use this and all of this by simply going into the Mailgun documentation. We're going to define a response object, which is going to be a post request. With this is going to actually send that post request, and it's going to check whether the status of the response is 200, meaning it was successful. It's going to print that the email was sent successfully. Otherwise, if there's something wrong with the network or something, it's going to give you an error. And if we try that, and I go, it looks like it succeeded, and I go to my email and it works. Amazing stuff. Next, we have a Google Drive bulk uploader. So basically, if you have a bunch of files and you want to upload them to Google Drive, and doing that and putting them into the correct folder is going to be pretty annoying to do manually. So why don't we just let Python do it for us? I've made this program for us, and for this, we're using the Google Cloud API. I would recommend you go actually read about it and the basics of how it works. Basically, a lot of this code right here is directly from the Google Cloud documentation. So basically, this function here basically just creates a connection between us and the Google Cloud. And before this, you would have to go on something called Google Cloud Console. You would create an account on here, then you would go on to your projects. Up here, you'd go on APIs and services, search for Google Drive, you click on enable to actually enable the ability to use Google Drive API. Then you would go hover over APIs and services, click on credentials, click on create credentials, OAuth client ID. You would basically just go through some of these fields, and then eventually you would be able to download this JSON file, which has a bunch of credentials for you to actually allow you to manipulate Google Drive and all the stuff using your Python code. You would save it in the same folder as your program with the name of credentials.json. You would make this exact function to create the connection, which is going to return credentials to actually allow you to then start doing a bunch of cool stuff. And this other function here is actually going to do the task of uploading a file from your computer to your Google Drive. And then this function here is going to be the outer function that we run. You're going to take the path to the directory. It's going to get the files using os.listdir, and then it's going to loop over those files, and for all of them, it's going to run the upload file function. which basically first creates a service with Google Drive, and then it tries to do a bunch of stuff to actually do it. And like the details of this is going to be the Google Drive API documentation, and at the end it's going to do it. If there's an error, it's going to return this except clause right here. Oh, and by the way, last thing you would need to find is this folder ID, which you would go to your Google Drive. You would go on Google Drive and you would open the folder that you want your files to be uploaded to. And then the folder ID is basically in your URL is going to be this string of text right here. After the folder slash, you're going to copy this into your code. And then basically, as long as you have defined the correct path to upload stuff from, which for me is this one, we're gonna now run this to see if it works. Hopefully I didn't make any stupid mistakes, and voila, it is right there. Isn't that magical? If it is magical, hit the like button. And last but not least, we have an investing return calculator, or like a wealth tracking calculator essentially. This is something that I personally find pretty cool because I'm really into personal finance, and the software app, the software startup that I'm using is a personal finance startup. So that's why a lot of these examples are based on personal finance. Basically, whenever you have savings, let's say you're saving $5,000 a month and you invest it, based on the return and the rate of return of your investment, you can calculate how much money you're going to have over a certain period of time. Basically, we have two different programs in here. We have calculate wealth by year. So it's going to take in your current wealth, current rate of return that you expect, how much you're saving per month, and for how many years you want to calculate your wealth based on these numbers. Obviously, this is going to change over your life and stuff, but this is going to give you an idea of what's possible. So we're going to first take in total savings, which is going to be initialized to the current wealth, and then 4 years from 1 till the year that you chose plus 1. It's going to calculate interest, and it's going to add the interest to the total savings, and at the end of it, it's going to print the total wealth at the end of each year. So if you run this, is first going to ask us to choose the program. I can choose return, a current wealth. Let's say I have $10,000. Let's say I have a 7% return, $4,000 a month, and we're gonna calculate for 20 years. Basically, this is pretty incredible. Even at this kind of savings rate, at the end of 20 years, I would have more than $2 million by the looks of it. And then we have this other function, which is gonna allow you to calculate how many years you're gonna have to spend in your life until you are financially free, which is basically the answer to the question of how much money would you need to live off for the rest of your life without having to work, which is my personal goal right now. It's just gonna run an infinite loop. It's gonna keep adding the interest as a savings until we reach more than our target wealth. So if we run this program, I'm just gonna move that a bit. Current wealth, let's say we have $10,000. Let's say return. Let's say I'm saving again $4,000, and then I need $500,000 to be financially free. Let's say that's my number. It will tell me it will only take me 8 years to be financially free, even at this savings rate, which is pretty incredible. And the way I'm doing this thing where it's choosing the programming stuff, basically I'm gonna use this input function. I'm first gonna ask the user which of these two programs he wants to run. If they choose to run the return, it's going to run the return function. If they choose freedom, it's going to ask still for the target wealth, and then it's going to run the calculate years till freedom function right here. And actually this year's is only relevant in here, so we're going to put that there. And basically, yeah, here it's just asking for those variables, simply using the input function and then the casting functions to make the strings into floats. And yeah, we are going to be using Python to automate our personal finances. You're going to be learning how to use CSV data and essentially clean it up using Python into exactly the kind of format that you want. The second thing you're going to be learning is how to use Python libraries. And the third thing you're going to be learning is how to integrate Python with Google Sheets. But why is this application actually useful? Ever since I started actually tracking my spending has actually gone down, because when I started actually seeing exactly where my money was going every single month, I started realizing that, oh, I am actually spending £100 a month just on subscriptions, half of which I don't even use. So are you excited yet? I am definitely excited. So why don't you grab a cup of coffee, open a code file in your favorite code editor, and let's get going. We're going to essentially do all the heavy lifting of setting everything up first, and we can just apply some Python magic to do a lot of magical things. First of all, we need a way to access our transactions in a file, which luckily most banks allow you to just download your transactions in a CSV file directly from your website. For this, I can't give an exact tutorial, unfortunately, because it is gonna depend on your bank. You just need to find a place to click download on your bank transaction sheet and then click on CSV. What CSV stands for is comma separated values. I have a couple of bank accounts and I've downloaded a couple of them. The one that I use the least, because for privacy reasons, I don't want to reveal all my bank transactions. We're going to import a library called CSV. And I would recommend naming these files in the same sort of format that I've done, which is the name of the bank underscore month. We're going to define a variable called file. We're also going to define a variable called month. The file name, we're going to do an F string, HSBC, which is the name of my bank, underscore, and then brackets, the month. Then you're going to type these lines. Essentially all of this does is allows you to access the lines from your CSV file. If you just go row in CSV reader, we're just going to print the row to see exactly how it's going to allow us to access this data. And it doesn't work because I forgot to add the ending to the file name. Here's what we get. And if you just compare it to the actual file right here, for my bank, the way they've organized the transactions is that every line is the date, the first item of the line, the second item of the line is the name of the transaction, and the third one is the sum of the transaction. Each of these rows in this CSV reader object is going to just be essentially a list where the first item is the date, the second is the name of the transaction, the third, the sum of the transaction. Before we do some more magic with these numbers, we're gonna need to do some more setting up, namely setting up access to our Google spreadsheets. And now there's gonna be quite a few steps here, but don't worry, I'm gonna walk you through every single one. It's all gonna be okay. Take a deep breath. And let's go. What we want to be using is this library called gspread. We're going to go pip install gspread. You do that. Now I've included a template down below in the description that you can download to get the exact same format in Google Sheets that I'm going to be using. The first thing you need to do is enable API access for a project. You're going to click on that, head to Google Developers Console. It's probably going to give you some window where there's going to be a create project thing. I've already done it, so I don't have that, but you're essentially going to create a project. After that, click on APIs and services and credentials. Create credentials, service account key. You fill out this form, you just give it some name and it automatically gives you this ID. Done. I don't really know what these fields here do. It doesn't really matter. I just left them blank. Then you're going to find your service accounts on this service accounts tab from the left. You're going to click on these 3 dots on the right, manage keys, create a new key. You're going to select JSON and it's going to download this file, which is going to be really important. It's probably going to go to your downloads folder. Next, what we're going to be doing is moving this file into this specific folder on your computer. And then you're going to call it service_account.json. And little secret, I don't even know exactly what it does. I'm just following the instructions here. Now your file is going to be in the right folder and everything should work. Now the last thing you need to do is you need to open up this JSON file using a text editor, and there's going to be this email address, client_email, which you're going to need to copy. Then you're going to go to the Google Sheets template that you downloaded from me, or if you created your own one, go to the top, you're going to click on share, you're going to copy the email address and then click done. Essentially, this is going to give you access to access your own Google Sheets file. Now, to see that everything works, you're going to go back to your code file, you're going to import, and you're going to paste these 2 lines with the name of the sheet file that you want to be working with. In my case, I've named it personal finances. And then we're going to run our code, drum roll. Let's see if this works. Everything works. We have successfully established a connection to our Google Sheet. Give yourself yet another pat on the back. Now we can start inputting our data from our CSV file using Python into our Google Sheet. First, we will need to think about, okay, what would be useful things for us to actually extract from our transactions? For me, it's the date, it's the name of the transaction, so where it went. There's a sort of category of what category of spending that was, as well as obviously the amount. As you can see here, it tells us the name of the transaction and it tells how much. It doesn't tell the category, but I'm going to show. But essentially what we're going to be doing is make our code a bit like AI, like a bit intelligent, where it's going to recognize what transactions belong to which category. Let's just grab the date. And the way we grab the date is that we can see that it's the first member of this list. So it's just going to be row bracket 0. Name is row 1. And for you, it's probably going to be different because your bank is probably going to display them in a slightly different order. It might have a whole bunch of data in here. You just need to go and look at this file and see which indices of these rows are the ones that you want. And lastly, we're going to grab the amount, and that's going to be row bracket 2. And for this, you can see it's actually a string. We want to grab this as a float, so we're just going to put it inside the float function. And we also want to know the category, but for now, we're just going to put category as other. And I'm going to show in a moment how you can make this a bit more intelligent with this. Then we're just going to create this transaction variable with the date, name, amount, and category, and at the end we'll just print it to see that it works. As you can see right here, now every transaction, we've got the date, we've got the name, we've got the amount, and we've got a category, which for now is just other. We're also just going to create this global variable called transactions. It's going to house all of our transactions, and for now it's just going to be an empty list. And at the end, instead of printing it, we're going to append it to the transactions list, making progress. Now, how can we make this category something other than just other? Just for this very simple version, what you can do is, like, for example, I know for a fact that this one right here, H3G DD, is my phone bill. So I can just go if name equals this. I can set the category to be phone bill, for example. And I also know for a fact this one is my Adobe Creative Cloud subscription. These names are going to be exactly the same because what we're going to be doing, we're going to be running the exact same code for all of our months. And ideally, all we'll have to do is change this month variable at the top. What I can also do, for example, is create this subscription names variable. And then I can go if name is in. So if name is one of these names, then we want to set the category to be subscription. Well, and there's an error because I've accidentally tried to append the transaction to itself. Now we can see that we actually have categories. The point here is that once we run this for every single month, next month, the code is going to know that if the name of the transaction is this, it's going to be a subscription because we've told it to. Okay, now we have access to all of our transactions. We have saved them in this transactions variable, but now we're going to apply the final piece of magic to get this to Google Sheets. And now at this point, if you don't want to use Google Sheets, you can go do with this data whatever you want. You can even do things like create a sum variable up here, and then this amount where every time is going to add, do the sum. So after all of these transactions I've run, we can also access the sum. So you can see exactly how much money went in or out of your bank account. We can immediately see that in March, my total was minus 63 pounds in this month. In June, it was 23 pounds, etc. But at this point of the video, if and only if you're enjoying this video so far, you know, my like button down below in the description has been telling me that she's been feeling a bit lonely lately. So we would both highly appreciate it if you could go down there, just give her a little tap. It would make both of us feel so good. You don't need to smash, a little tap is enough. And to show both of our appreciation for you doing that, here is a picture of a cute dog with some flowers. Thank you so much for doing that. Now let's get back to the project. Okay, if you do want to input this into Google Sheets, what you're now going to do is after these lines of code, you're going to access the worksheet that you want. By going worksheet equals sh.worksheet and the name of the worksheet. Now, the way I've done it in my template is that each of the sheets is just named after the month. And because we've already got the month variables named up here, we can just dynamically access the correct sheet using this name right here. And then we're gonna create a variable called rows, which we're going to get by running this function up here. So actually what we're gonna do here is wrap this beginning part of this code in a function. I'm just gonna call it hsbc fin, taking in the file and the subscription names. Indent this, and instead of printing stuff, we're going to return transaction. And we're gonna want to access these transactions in here. So we're going to go hsbc fin to run this code using the file and the subscription names. Now in this row variable, we've got the transactions by running this file. Before we do anything, to see how we insert data into Google Sheets. So in this function, the first argument is going to be a list of the values that we want to insert. And there's going to be a second argument, which is going to be the number of the row where we want to insert this information. So as a test, we're just going to go 1, 2, 3 to row number, let's say row number 10. And now we're gonna see what happens. For now, all of this is empty. Now, when we run this code, let's see if it works. It's loading. And as you can see, we've just inserted some data into our sheet. And for example, it thinks that this is a date. We're not going to worry about that. We're just going to delete that. And now to actually insert the data that we want, which is our transactions, what we do is for row in rows. Now we need to think about what order we want to insert this in. So first we want the date, then the description, then the category, then the amount. And the way I've designed this template right here is that we want to start inserting from this 8th row. Put row number 8 as the place where you want to insert it if you're using this exact template. And another thing that we just want to do is we want to import time. I'm going to go time.sleep for 2 seconds. So essentially what this does is that after inserting each row, it's going to sleep for 2 seconds. And the only reason for this is because Google Sheets has like limits on how many times you can access the API per second or whatever. So we just want to make sure we don't overload the API. So we're going to wait for 2 seconds after each row. So now let's see what happens. And as you can see, the transactions just start appearing on your Google Sheet every 2 seconds. Pretty darn magical. Python magical. So essentially, all you now have to do is download your CSV for every single month that you want to do this for. Just change this month at the top. Or you can even do this using shell scripting to like accept the month as a command line argument. I've already taught how to do this in this video that I made previously, so I'm not going to do that again. But obviously there's a whole bunch of things that you can now do with this. And add them to this one summary sheet where you can see all of your months at the same time. Obviously this is specifically for like my needs, how I would like to categorize my things. Just look at how these commands are formatted and you can do everything. What it does here is that if the category of the transaction is a subscription, it is automatically going to grab it to this line of the summary sheet. Now, this is a very simple version of my own program that I use myself. In my own program, there's a whole bunch of other complicated things as well. For example, because I'm in a situation where I have bank accounts in both the UK and Finland, so I'm sort of need to do things for like to automatically convert the currencies. All these functions for all of my bank accounts, including PayPal and all of that. There's all this like checking to see like if the name is something, then it's in some category. And I've got all these functions for like cleaning up some of the dates, and I've like sending the data to a database, and there's a whole bunch of things that I've iterated over multiple times. But hopefully this video gave you an idea for the most basic version of how you can start tracking your finances using Python and categorizing it. First project is going to be a website automator. Now, every time you go on your computer and you open up your browser, what do you have to do? Well, you have to open up some web pages. And chances are, when you're doing a specific task, let's say you're working on a school project, or you start working on your latest coding project, you have certain tabs that you're going to want to have open while you're working on that thing. For example, if you're going through my paid program, Python Development Bootcamp, sneaky plug again, you're going to want to have the program open. Then maybe you have your notes open. Maybe you have some tutorials open. Let's say you're figuring out one of the practice projects. It's quite cumbersome to have to always manually open up all of these tabs when you start working on something, and then manually close them and manually close a set of other tabs when you want to do something else. And so because doing that is extremely boring and annoying, why don't we just automate that using Python? Let's do it. So we're going to make a file called website _automator.py, and I'm going to spell that correctly. Like that. We're going to close all of these other ones because we don't need them, and we're going to start coding. So for these purposes, we're going to need 2 libraries that we're going to want to import at the top here. One of them is going to be sys. One of them is going to be web browser, and you might have to install this. I'm not actually sure. If you do, then the way you do that is by going pip install web browser like that. Okay, it looks like it could be simply a built-in library, whatever. So what we're going to do is define a variable called URLs that is going to be essentially an object that has different sets of URLs for different tasks that you want to be working on your computer. To illustrate, you might have a set of URLs that we're going to label as work. That's going to have the value of a list of URLs, like for example www.slack.com, google.com, whatever are your work tabs are going to be in this tab group right here. And then you might want to have something else for your personal life. We're going to have personal, which might include, I don't know, Netflix or Spotify, youtube.com. Now what we want to achieve is that just by running this program with a specific keyword that corresponds to some of these names of these tab groups, then what this web browser library can do is simply open up those URLs using the default browser on your computer. So we're going to define a function called open web pages that's going to take a set of URLs as a list, as a parameter, and then we're going to loop over these URLs by going for URL in URLs. So this is simply running a Python for loop where in each iteration, this URL variable is going to refer to each given URL in the URL list, for example, this list right here. Then all we have to do is using this web browser module, which by the way, you would simply find from the documentation of this web browser library, how specifically to do this. But you're going to call this method called open underscore, and if you just scroll down, we're going to see this straight away, open a new tab with this URL, just like that. And right now, I'm just going to test this out to make sure that this works. So I'm going to call open web pages, and I'm just going to use URLs and indexed with personal just to test this out to make sure that this works properly. So we're going to run this, and what is going to happen? Nothing is going to happen. I wonder why that is. So I'm actually going to go to the web browser library to figure out what I have done wrong here. Okay, perhaps I can just use open. Let's see if this works. Okay, looks like we need to have the full path with, I believe, the HTTPS in front of it like that. I just had this formatted incorrectly, and that's why it wasn't working. And there we go. That is very good to know, just like that. So now to finalize this project, what we're gonna go is if underscore underscore name underscore underscore is equal to, and bear with me on this, underscore underscore main underscore underscore. So what the hell are we doing here? Well, this is essentially simply saying that if we are running this program directly, as in this is not being run from some other file, like if someone was importing this file into some other file, technically it's going to run through the file. But in that case, we don't actually want to run this code that is inside of this if block in here. We only want to run this if block if this file is being run directly from the terminal. That is simply what we're saying here, but you don't need to care too much about that. What we want to do is allow the user to set the name of the URL group that we want to open as a command line argument. And the way we do that is, first of all, let's just get a variable that we're going to set that to. And that's going to be sys.argv. Now, argv is going to be a list of all of the command line arguments that we give to the program. What do we mean by command line arguments? Well, when we're running this like this, going Python, web, site automator.py, whatever we give after this program name is going to be the first command line argument. Let's say we give it personal, that is going to be the first command line argument. Then let's say we give AAA, that is going to be the second command line argument, etc., etc. The way we want to use this is that whatever is the first command line argument is going to be the name of the particular URL group that we want to open. And so what we're going to do is give it sys.argv1, and it's 1 because technically the program name, which is right here, this one, website underscore automator.py, is going to be the first, so the index 0th command line argument. But that is not what we want to access. We want to access this second one. Then what we're going to do is go URLs is equal to URLs indexed by this set name, and then simply go open web pages with these URLs like that. And we're actually going to put this to uppercase to make sure that we're not confusing because this is URLs in lowercase and this is URLs in uppercase, and just like that it should work. Now once we run this project right here, website automator personal, boom, all the web pages open up inside of my web browser window just like that. And ideally what you want to do is add some error checking and things like this to make sure if, let's say, we give some weird name like personal, something like this, then obviously it's just going to give a trace back. You might want to have some error handling and things like this for that. I'm going to leave that to you as an exercise, and the code down below is going to be a bit more robust. It's going to have that error checking. But here I just want to show you the idea of the project. Very, very simple project with like 19 lines of code. We have been able to code something pretty interesting, if I say so myself. With that, let's move on to the next one. So our next project is going to be a fake Twitter influencer. Now let's say you want to become an influencer just like me, but you don't have the skills to make these fabulous YouTube videos. Don't worry, because we can actually help Python make you an influencer automatically, pretty much. This won't happen on YouTube, sadly, but we can make this happen on Twitter or X, whatever it's called these days. The way this is going to work is that we're going to have a code file with a list of programming jokes. And then we're going to use the Twitter API to automatically, in a certain interval, whatever you define, post these programming jokes on Twitter on a separate Twitter account that you have created. Now, of course, this is just an example. You could make any kind of Twitter bot using this same code. And I, of course, encourage you to figure out your own automated Twitter influencer that you want to make, because otherwise we'll just have a bunch of coding humor influencers out there. Now, the way this is going to happen is in a couple of steps. What you're going to have to go to is developer.twitter.com. You're going to access the Twitter API developer portal. Essentially, you're going to have to create a Twitter account, log in, unless you have one already, and then there's going to be a button where you're going to essentially request access to the Twitter API. I believe you need to give some reason as to why you need access to it or something like that. Shouldn't be difficult to get approved or anything like that. Once you do that, you're going to have this dashboard over here, and there's going to be a button here for you to create a new project that is going to be the project for your Twitter bot. And inside of it, you're going to create something called an app, where you're going to have to give it a name, fill out some details, and as soon as it gets approved, you're going to have this window right here where you have your Twitter API project. And inside of here, you're going to be able to click on keys and tokens. This is going to give you access to your API key and secret that you're going to need to access the Twitter API. Basically, the reason you're using this is that you have these keys that Twitter has given to you to essentially authenticate yourself and tell Elon that you are one of the good boys and you're not trying to like hack Twitter or something like that. Now, the way the code is going to work as follows. You're going to have these two lines of code in here where you're going to copy your API key and your API secret. I've just hidden them from you here so that you can't see mine. And then at the top here, you're going to import these couple of libraries: time, OS, JSON, and then from request_OAuth_lib, you're going to import OAuth1 session. Then what we're going to have is a Python list of programming jokes. Now, I simply got this list from ChatGPT because I am boring and I have 0 programming jokes inside of my brain, but you're free to come up with your own. We're going to have these lines of code in here, which are not very interesting. So we're not going to actually go over this. Basically, what all of this code here does is takes care of the process of you authenticating yourself using these API keys that you got before with the Twitter API. Now, I simply got this code from ChatGPT. Even I don't fully know every single step in here. You're not supposed to really. Really, you would get this from AI anyway. So I don't think there's point in us going over this. You can just get this code. So basically from line 25 to 72 from the code file that I have listed down below in the description. But just to give you an overview, what happens here, we have this request URL, which we have found from the Twitter API documentation, which we can find at developer.twitter.com/en/docs/twitter-api. All of this is going to be linked down below in the description, just in case you're wondering where I found all these URLs. And then using that, we're going to create something called an OAuth1 session using the OAuth1 library that we imported above with the key and the client secret and things like this. Then we're going to get a response from that URL. And from that response, we're going to save a couple of details, print some stuff. Then we're going to have this authorization URL. We're going to do some verification, and then eventually we're going to get what's called an access token, and we're going to save these inside of this file called Twitter_tokens.json. And the reason we do that is so that every time we run this bot in the future, we won't have to go through this authorization flow every time. And just to show you how this works, when I run this for the first time, what is going to happen is this. You're going to get this authorization URL, which you're going to want to open inside of your browser. And then what is going to happen is you're going to need to log in to the specific Twitter account that you want to associate with this bot. Maybe it's your actual Twitter account, but in my case, it's a different Twitter account. So what I'm going to want to do is sign out of my actual Twitter account and log in to my other Twitter account. After you do that, you're going to get this pin right here, which you're going to copy and you're going to paste over here where it says paste the pin here. That is going to associate that Twitter account with this particular Twitter bot. Now, what we're doing here is creating this file called twitter_tokens.json that is going to simply save some of these access tokens as a file, so that next time what's going to run is these lines right here, where it's going to check if this file essentially exists, and then it's going to open that file and get these tokens from there and set these access tokens as variables without needing to run through this authorization flow. Then what we can do is get to the more interesting part of this code. What is going to happen is that we have this function run_bot, where we have an infinite loop where we run this post joke function with this jokes wrist as a parameter, and after we do that, we sleep for 6 hours in this case. So you could sleep for any amount of time that you want to essentially make sure that there is a certain interval at which these tweets are posted. And it is in this post joke function that most of the magic happens. First of all, we are going to get access to something called an index that's just going to tell us what is the number inside of the jokes array that we want to access next. So what we're going to do is open this last joke index file, and if it doesn't exist, then it's just going to return -1. But this file is going to keep track of what is the index within this list right here of the joke that we want to post next. And then from that, we get the next index by going last index +1, and we get the remainder when dividing it with the length of the jokes list. So basically, as long as it's smaller than the length of the jokes list, then it's going to be the actual index within the list. If it is more than that, then it's going to essentially start over from the start of the list. With that, we're going to get the joke that we want to post next from the jokes list, indexed by the next index. We're going to have this OAuth session that we're going to need, because using that, we're going to go OAuth.post into this particular Twitter API endpoint with api.twitter.com/2/tweet. And when we send to it a post request with a payload that is an object with the key text and the value joke, that is going to post this text within this joke on Twitter. And then we just have some checks based on the status code to make sure everything went correctly. And then we're going to save this index of the joke that we just posted using this save index function, where we open this last joke index.txt file and we write to it the next index. Now you can pause this video at any point if you want to code this along with me, or you can go and get the code down below in the description and modify it to your purposes. The core here is not the particular code that I have written here, which is why we didn't go through it line by line, but rather being able to use an API like the Twitter API to create something interesting that you actually want to create yourself. Again, all of the links to the Twitter API documentation and everything like that is going to be linked down below in the description. With that, let's move on to the next automation project. All right, on to the third and last project of this video. Now, one of my favorite use cases for programming in general is to play around with my personal finances. What I like to do is keep track of all of my personal finances. I'm a bit of a nerd when it comes to all of these. But doing all of this manually is the most boring thing you'll ever do in your life. Luckily, with Python programming skills and just a bit of basic code, you can achieve some incredible automations when it comes to finances. Now, I've done other videos on other specific use cases for financial automation before, and I keep sort of improving these scripts that I make for myself over time. So in this one, I'm just going to show you a very simple one that's already going to achieve a lot. So our goal here is to create a script that is going to essentially give you this kind of file right here, monthly expenses, where for any given month, you're just going to have a number with all of the spending that you did in that given month. Now, this is just a simple one. You might imagine making this as complex as you want. You might imagine having a separate item in this JSON file for income and then one for expenses. And you might imagine having all your spending categorized based on like where you're spending it, your top sort of merchants where you're spending money, so you can really start seeing where your money is going. But for the purposes of this video, we're just going to create something simple, and then you can take this project and expand it in any way that you want. So what we're going to get started with is as follows. We have a file here called finance_tracker.py, and we're going to start off by importing a few things. We're going to import CSV. So this is going to be very, very important. We're going to import JSON, and we're going to import OS. And of course, I'm going to have those on different lines. Do not be an idiot. The way this is going to work is that you're going to have to go into your bank and get access to a monthly statement of all your bank transactions in CSV format. For example, I've got myself one of my transaction reports right here. Basically, for my specific bank, the file is going to look like this, where you have the date, details, amount, currency, whether it's debit or credit, and you have the status. Now, what the specific function to essentially extract all the information that you want from this file is going to look like is going to depend on what your specific CSV file looks like. Now, these are all different, unfortunately, for all different banks and all different countries. So for me, I'm just going to copy paste this in here, because for you, you would have to code it up manually from the start anyway, so you can use this as a starting point. But for me, essentially what happens here is that we are opening a CSV file that we're going to give it to this as a CSV file path, and we'll do that later on in this project, and we're going to have access to this file as the CSV file. Then using the CSV library, we're going to go csv.reader with the CSV file to get access to this reader object that is going to give us access to a bunch of different functionality for this CSV file. And then because I can see that from my CSV file, the first 3 lines up here are actually not something that I want, I'm going to have to skip through 3 lines. So I'm going to go next, which is simply a function that allows us to skip through a line in our CSV file, and I have the reader as the object over here. And then after I've done that, I'm going to loop through all the rows in this reader, and then I'm going to check if the row corresponds to the given month and year, and if it is a debit transaction. So debit transaction essentially means that it's a debit transaction rather than a credit transaction, where a credit transaction is money coming in. I'm only interested in transactions with money going out. So I'm going to get access to these different items from this line by simply creating these different variables from this row. And then I'm going to get the amount by going amount.replace, where I'm replacing a comma with an empty line, because you might be able to see here is that, let's say in this transaction where it's 19,604, I don't want the comma. I simply want the number, so I'm going to replace the comma with an empty line. After that, I'm going to check if the transaction type is debit, and only in that case I'm going to add to this total expenses variable that I'm creating up here the amount that I am casting in the float, and then I'm at the end going to return total expenses. So what this essentially does is it grabs this transaction CSV file and then extracts from it all of the debit transaction and adds it to one variable that I'm going to simply return out of this function. That is the purpose of this function. Now moving on, let's look at what the main program is going to look like. So when you run this program, what you're going to need to give this Python program is a couple of details. First, we're going to have the month input, which we're going to grab from the user using input, and we're just going to ask, please enter the month, and we're going to give the format will be year dash month like this, and so we're going to get that from the user. Then we're going to get csv underscore file underscore name, which we're simply going to make this transactions.csv file, which is what we have named it. Then we're going to get the JSON file name, which is going to be the output file that we're actually interested in creating. We're going to set that to be monthly underscore expenses .json, monthly, like that. And then what we're going to do is get total underscore month underscore expenses. It's going to be equal to sum expenses for month, and we give the CSV file as a parameter, just like up here, as this function expects. Then we're simply going to print these total expenses using a Python f string total expenses for, with the month input r, and we're just plugging in total month expenses, which is the output, the return value from this function right here. Now all we have to do is update this JSON file with the result of this sum expenses for month return value. And for that, we're going to create one more function that is going to be called update underscore expenses underscore JSON. And what this is going to expect is a JSON file path. It's going to expect a month, and it's going to expect total underscore expenses. What we're going to do is create an empty object called expenses underscore data, which is going to be equal to an empty object. Then we're going to check if os.path .exist, which is simply checking if the path to this file that we're giving it, which is the JSON file path, exists. In that case, we open that file using with open, which is a function in Python that we use to open files and access them. We open JSON file path as JSON underscore file. After that, we add expenses data. We set that equal to JSON.load JSON file. After that, we update this expenses data for the month that we gave to this function with the total expenses. And notice, if this file doesn't exist, we're simply going to have an empty expenses data object. And then with, again, open JSON file path in read mode, or actually in this case, I guess write mode, of course, as JSON file. We're now going to write into this file the new data, which we're going to do by going JSON.dump, which is simply the JSON function to do this with expenses data, a JSON file, an indent of 4 to just make it a bit nicer to read. And now with this function at the end of everything, we're going to run update expenses data with the JSON file name, the month input, and the total month expenses as variables. And that should take care of everything. Now let's see if this works properly. Let's run this file. We're going to input end of the month, so we're just going to input, let's say April. Actually, well, of course, that's not the format. It's 2024-04, like that. Total expenses for that month were apparently this much. And once you go to this JSON file, you will see that it has updated. Now, of course, in this case, I use the same file for both of them, so that's why it's the same. But what you would do is every month you would get your CSV and upload it to this folder, and simply probably you would want to actually in this code also ask for maybe a specific format of the name for the CSV file, and then you could just give it dynamically. But I will leave all of that to you as an exercise to make this a bit better. Just the basic idea is that just with this Python script, you can have information about your spending in one place, so you can keep track of your finances a lot more easily without having to go and look at, like, add up some transactions to some Google Sheets or something manually. Now, the first project we're going to start off with is going to be very simple. It's going to be a quiz game. The idea here is this. I'm going to show you some footage of the completed version on the screen now. But essentially, you have a series of questions, and the program is going to simply ask you these questions and give you some options for the answer, and then you are supposed to guess what the answer is. And then while this program is running, it's going to keep track of your score. At the end, it's going to print your score to you or something similar. So what we're going to start off with is a list in Python that contains objects, so aka Python dictionaries, with different properties, where first we have the prompt, which is the question. We have options, which are the options for the different possible answers, as well as the correct answer for the question. And then in a second, what we'll do is now loop over these objects and then print first the prompt, then print the possible answers, and then ask the user to give either A, B, C, or D as the answer. And if it's correct, we're going to increment the score of the user. And if it's not correct, we are not going to do that. And basically at the end, we're going to print that. So that is the idea here. What we're going to do is start by defining a function called run quiz. And then what we're going to do is take these questions as a parameter, which means that we are, of course, going to have to move that up top just like this. So this is going to be a function that we are then going to run at the end. So the first thing we need to do is initialize a score variable at 0, which we're then going to keep track of throughout this program. Then what do we need to do? Well, we need to somehow loop through all of these questions and ask them all in order. So we're going to run a for loop for question in questions. So if you're not familiar, this is running a loop through all of these items, where in every iteration of the loop, all the code inside of this loop, which is going to be indented inside of this for loop, is going to run. Where at each iteration, this question variable is going to refer to first this one, then this one, then this one, then this one, etc. And of course, you'll be able to customize this array with any questions and answers you want. So first, what do we need to do? Well, we need to print the actual question on the terminal, which we're going to do with this line. We're going to print question prompt. So we're accessing the prompt attribute of this question object from here. So we're accessing this one and we're printing it on the terminal. Good. Well, then we need to print all of these. So of course, what we could do is simply print question options as a list, but it's gonna probably look a bit better if we actually print them line by line. So we're actually gonna also loop through all these options. So for option in question options like this, we're then gonna print the option like that, and we're just gonna run this right now to see what it looks like for now. And actually, well, of course, nothing happens because we're not running the actual function. We're gonna run quiz with the questions as the input. So this is what's gonna happen. What is the capital of France? It's gonna print the options, etc., etc., etc. Do that for every single one. Now, what do we need to do? Well, we need to ask the user for the answer. And so the way we can stop the run of this program to like wait for input from the user is using the input function in Python. If this is new to you, then don't worry, because I'm going to show you how this works. So we're going to define a variable called answer and set it equal to input. And then what is inside of this input is going to be the prompt, so sort of the question that we want to print to the user. I'm going to show you in a second how this works. So we're going to print something like this: enter your answer. And so just to show you what's going to happen, basically this is going to run the first iteration of this loop. It's going to print that, print these, but then the run of the program is going to stop. It's going to wait for me to give this program something in here. Once I give A, then it's going to do the next one, etc., etc., etc. Of course, we're going to stop that right there, and we're going to need to do something else, but that is essentially what happens here. So now this answer variable is going to contain whatever I give to the program as a string. Now that's important. It's going to be given as a string always. So what do I need to do is I need to check if this answer is correct, essentially. So I'm going to compare this against the question answer property, which is going to contain the correct answer. So if these are equal, then I know that our user successfully gave us the correct answer, in which case we can do something like print correct, hooray, or whatever. And I'm going to also print something like this /n, which is going to tell our program to print an empty line after that. And it looks like we have a typo. Correct it just like this. Now, if we are correct, we need to remember to increment this score variable. So the way that happens is doing something like this: plus equal to 1. What plus equal to does, it takes whatever is the value of score right now, and it increments 1 to it, and then it sets the new variable with +1 compared to the previous one as a new value of score, just like this. And in the else case, if we are not correct, we are not going to do anything to the score. We're just going to print to the console to tell the user what a complete loser they are for not knowing the correct answer. The correct answer was, and we're going to be a bit mean, we're going to say wrong loser. The correct answer was this. And then at the end of the program, so when this entire loop, so now these lines will run for every question, essentially. After this entire loop has run through, we still probably want to just print what the score was and things like this. So we're going to print something like this: you got score out of blah, blah, blah. Questions correct. So what is happening here is we are, first of all, we're using something called an F string in Python. So when you put an F in front of the string, it's going to allow us to plug variables inside of the string that we're printing with this print function, like this, where we use these squiggly squiggly brackets, whatever these are called. And inside of them, we can put the variable name, and that is now going to be printed inside of this string. And we're accessing the length of the question to tell us how many questions we had. And just like this. So now if we run this, we can see what's going to happen. Where's the capital of France? Well, it is Paris. Correct, hooray. Which language primarily is spoken in Brazil? It's going to be Portuguese. Now the next one is the smallest prime number. Now let's say I have no idea and I'm a bit of an idiot and I say D. This is going to tell us that we are a loser. Who wrote To Kill the Mockingbird? Actually, I have no freaking idea. Actually, I do. Hemingway, right? No. God damn it. Well, as we can see, we got 2 out of 4 questions correct. Now there's one more optimization that we probably want to do, because let's say we run this again and I'm a bit careless and I don't realize that I actually have to input this answer in uppercase. The thing with programming is that programming languages are always going to take us completely literally. So let's say I put A in lowercase, it's still going to say wrong, which might sound strange, but it actually makes sense, because in this program we're specifically comparing here the answer to the question answer, which is always going to be uppercase. So if we give a lowercase a, then that's still going to give us a wrong answer. So we might not want that. So what we might actually do here is when we're getting this answer, we're going to append it with this function called upper, It's going to take whatever we give it, and if it is not in uppercase already, it's going to put it into uppercase. So even if we give this answer in lowercase, it's still going to compare it properly, essentially. So I'm going to run this again. We're going to give A in lowercase, and it's still going to say correct. That is probably what we want. So now, this is sort of the basic version of this. What I want you to do, if this interests you, you can of course add your own questions array, and you can absolutely just go and play with your dad or your friends in your own Python quiz program, which is pretty cool. But that is the quiz game. By the way, all of this code is going to be down below in the description if you want to take this code and then go and expand it in your own ways, which I always recommend. Our next one is going to be Hangman. So the idea here is that we're going to be playing the Hangman game. You might have played it at school or something. The idea is that someone chooses a word, and then we tell the other players how many letters are going to be in that word. And then one by one, the people playing the game are going to be guessing letters. If the letter is included in that word, those letters are going to be placed in the correct spots in the word, on the board, or wherever it is. Or in our case, it's going to be in our terminal. And then there's going to be a certain number of attempts by which we have to guess what the word is. And if we do, then we're hanged and we die, essentially. So high stakes here. So we're going to make a Python version of this. We're going to create a file called hangman.py, and we're going to get started. First of all, we're going to define a list of words. That's just going to be a list of random words that, for the sake of this example, are going to be the words that we're trying to guess. Then we're going to have to import something called random, because what we're going to do is we're going to choose a random choice of these words, which is going to be the word that we're then having to guess when we're playing the game. And the way that works, what a random is a built-in library in Python, which we're importing, that gives us access to a lot of random operations, essentially. Now, this might be new to you, and if so, then, well, now you know how to use it. The way this works is that we go random.choice, and then we give this choice function a list of the words or whatever we want to get a random choice from. Then so now this chosen word is going to be a random choice from one of these words in here. Then we're going to create a word display, which is essentially going to first just look something like this, where you just have underscores that is of equal length to the chosen word. So this might be new syntax to you, actually. We're essentially running a for loop, where the result of that for loop is going to be a list, where every element of that list is going to be this underscore. And the way this works is that it's going to be a list that is going to run for every element in this chosen word, where now every element of this chosen word is going to be actually every character of this chosen word. So for example, in the case of Python, this for loop is going to run. In the first iteration, we have P, then Y, then T, then H, then O, then N. And then for every one of these items, a new instance of this underscore is going to be appended to this list. So I'm just going to show you what comes out of this, so I can show you. So I'm going to print word display, and I'm going to run this. So just like this, we're going to have a list with underscores. So whichever one of these words was chosen, I would assume it's probably JavaScript, maybe. Actually, no, I don't know. Anyway, this is going to be this word display list. So we're not going to have to do that. Then we're going to give some number of attempts to our user. How many wrong attempts are they essentially going to have to guess these letters? I'm just going to give 8. You can give whatever number you want. And then we're going to print welcome to Hangman, and now the game is going to start. So what do we have to do? Well, we're going to run some sort of a semi-infinite while loop, where essentially these rounds of this game are going to keep running until one of two things happen. Either until the entire word display is filled with the correct word, or until we run out of attempts. So essentially we can go while attempts is more than 0, right? While we still have attempts left, this game is going to keep running. And while there still is an underscore in this word display. Now, the way this works is that it's going to check if this word display array includes at least one item of this underscore. That means we still have letters left to guess in the word display. Therefore, the game should keep running. So while both of these conditions are true, our game is going to run, and this is going to be the game. So we're going to start by printing first a new line, plus then sort of cryptically empty character, whatever, dot join word display. Okay, what the hell are we doing here? Well, let me just show you. So basically, this is what's going to print, and okay, it keeps running infinitely. What we're simply doing is we're taking an empty screen and we're concatenating it with every element of this word display, which for now are these underscores, and we're printing that just for the user to show them how many characters we have in our word. And then we are again going to ask something from our user. What we're going to ask is something called a guess We're using the same input function to ask for them. And the prompt is going to be guess a letter. And then we're going to put that letter into lowercase. So in case we give it the letter in uppercase, we want it to be lowercase. So now we have a guess, which is going to be a lowercase letter that we got from the user. So what do we have to do now? We have to check if this guessed letter is inside of this chosen word, which by the way, the user is not going to know, obviously. So we're going to check if guess in chosen word. Then what do we have to do? Well, we have to then modify this word display such that the places where this letter guess appears, this underscore is now replaced by that letter. So we're sort of revealing that letter. So there's maybe many ways to do that. The way I'm going to do this is I'm going to run a for loop where I'm going to access the index of the word as well as the letter itself. So what is the letter in the word? And the way I can do that is by calling enumerate with the chosen word, just like this. So what enumerate does, if you hover over it, okay, well, this description is not useful at all, but what it essentially does is it takes this chosen word and it gives us access to both the actual letter in any iteration of the for loop through this word, as well as the index of that letter. So indexing starts from 0. So let's say we have Python. In the first iteration, letter is going to be equal to P and index is going to be equal to 0 because we start indexing from 0. In the second iteration, letter is going to be equal to Y, index is going to be 1, etc, etc, etc. That is how it works. I'm going to show you now why we do that. So first of all, what we do is if this letter is equal to the guess, then we're going to go to the word display and we're going to replace the corresponding index of that with the guess itself. Now, if that doesn't make sense, in a minute, you will see why we do that. So what this is doing is it is essentially revealing the letter. And then in the else case, if the guess is not in the chosen word, what we have to do is, first of all, we're going to print that that letter doesn't appear in the word. And we're going to be mean again. We're going to go idiot. It's like this. You don't have to be as mean as me. And then what we have to do importantly is go to the attempts and now deduct it by 1. So similarly, previously we had plus equal 1, which was appending the variable y1. Minus equals 1 is deducting 1 from that variable, just like this. So now this loop is going to keep running for as long as we have attempts left and as long as there are still underscores, aka as long as we still have unguessed letters inside of this word. So at the end, based on the result, we're just going to print a couple of things. Either we guess the word or whether you ran out of attempts, etc, etc, etc. I'm just going to show you how this works now. Okay, so this is going to be the word. So I'm going to see, okay, it could be Java. So I'm going to say G. This letter just not appear in the word. Okay, what else could it be? I know these are programming languages. Swift. Obviously, it's not that. I'm going to have to cheat. Okay, it's probably Ruby, right? So I'm going to go R. Okay, there we go. U, B, Y. Just like this. And we guessed the word. Obviously, I had to cheat by looking at this actual array, but that is the game. I encourage you to perhaps take this a bit further. You can, again, this game that you can literally go and play with your friends and you can showcase your amazing programming skills. They probably won't care, by the way, but it's good practice nevertheless. Okay, let's move on to the next one. Now, this one is cool. We're gonna make a budget tracker. So the idea here is that you can set yourself a budget. And then whenever you have expenses, let's say you buy coffee for $5 and you buy whatever for $50, you can then just add those expenses into your program in your command line, and then you can print whatever budget you have left for the month or for the week or however you want to do this. So just to save some time, I'm going to first print to you how the main program is going to run. So I'm going to define a function called main, which is going to be the function that's going to be run when this file is run. So usually in Python, when you have several functions in a file, you add this line at the end where it says if underscore underscore name underscore underscore equals to underscore underscore main underscore underscore, weirdly, then we run the main function. That's just basically checking that we are running this file sort of properly from the command line. So what's going to happen is going to print welcome to the budgeting tracker app. And then it's going to ask for the initial budget, or what is the budget that we wanted to set for ourselves. It's going to get the input, and remember, the result of the input is always going to be a string. And so we want to turn that string into a float, which is a type of number with decimal points. And we do that with this float casting function. So this initial budget is now going to be of type float. It's going to be a number that we give it. There's some lines that are commented out here. We're going to get back to those later because there's actually a bit of a problem with this initial implementation that we're going to do. Then we're going to set the budget to be this initial budget. And we're going to set an expenses. It's going to be a list of expenses that we're then going to be asking from our user. So then we're going to run what's called an infinite loop. So while true, so essentially this loop is going to keep running forever until we manually end this program. So we're going to print what would you like to do, either add expense or show the current budget, or exit the program. And then we're going to get the choice, either 1, 2, or 3 from the user. And then if the choice is 1, so we want to add an expense, we're going to ask the user for the description of the expense as well as the amount of the expense, which again we need to remember to cast into a float. And then we're going to run an add expense function, which we're going to define in a moment. Similarly, if the choice is 2, which is to show the budget, we're simply going to run the show budget details function, which again we're going to implement in a moment. And lastly, if we have 3, then we're simply going to break, which is going to break out of this loop and end the program. Now, first, the most important thing is going to be this add expense function. So we're going to go and define add expense like this. And what's going to need to take is the expenses, which is all the expenses, as well as this description, as well as the amount of the expense that we're trying to add. Now, what do we need to do? Well, this expenses variable is going to be a list of objects where every object is going to have a description and it's going to have an amount. So we're simply going to go to expenses and we're going to append something like this, which is an object with description of the description that we gave it and an amount attribute of the amount. And then we're going to print to inform the user that this expense was added. And an important detail about how Python works is when we give this expenses list to this function and we append to it, that change is actually going to apply to this expenses variable even outside of this function. This is related to a concept called object reference parsing. I made a previous video about 5 crucial Python concepts that you should learn as a beginner Python programmer to take yourself to the intermediate level. I'm going to leave that video down below in the description. If you want to go into it, we'll go into this and 4 other concepts in more detail in that video, but just good to understand. So that is the add expense function. Then we're going to define the, what was the other one? Show budget details function, which is going to take in a budget variable, which we're going to give it, as well as expenses. And inside of here, we're first going to print the total budget, again using f strings. We're going to print total budget is budget, and then we're going to print expenses colon, and then we're going to loop over these expenses and print all of them just like this, where we print the expense description as well as the expense amount. And then, and obviously you can do this however you want, but I'm just doing it like this, where at the end, we're simply giving total spend, which is going to call a function called get total expenses, which we're going to implement in a second, as well as get balance. So in fact, let's implement these functions right now. We're going to go def this, and we're going to need to take expenses. So essentially we want to sum together all the amounts from these expenses lists and then return that from this function. So we're going to initialize a sum at 0 and then for expense in expenses, we're going to then add the sum the expense amount, just like this. And then at the end, we're going to return sum, just like this. Then we're going to need to define this get balance with a budget as well as expenses. So here we simply need to take the budget that we had initially and then deduct from that the total expenses that we have spent so far, so that we can here print what the remaining budget is. So very simply, using this function that we just defined before, we're going to simply return budget minus get total expenses with these expenses, just like that. Now this one should work. Well, that seems to do it, because we now have the show budget details function, and we also, well, in the last one we didn't need to define any more functions. So that should do it for this basic application of this program. So we're going to test it out. Please enter the initial budget. I'm going to put 10,000. What would you like to do? Well, I like to add an expense. Let's say I spent $100. Expense amount. Actually, well, that was the description. I messed up. Anyway, it doesn't matter. 100. Now we want to add another. Okay, let's say groceries. Using this properly this time. I don't know, 56. Okay, now we want to show budget details. Looks like we have a total expenses that we've spent. It's going to list them out very nicely, just like that. and then it's gonna give us total spend this and a remaining budget of this much. Now, there is a bit of an issue here because let's say I exit from this program, which might just happen when you like turn off your computer or something like that. Now, when I go and run this program again, what I'm gonna have to do is reset everything, like all my expenses, everything is gone. So what we might wanna implement is something called persistence. We want some way to store the expenses and the budget somewhere outside of just variables of this program, because all these variables, when you stop running the program, are going to be reset and they're going to disappear. And that is where these lines in here are going to come in. So what we're going to do is have a JSON file. So JSON is essentially like a type of data format that we often use to like store simple data in actual files on our computer. And then what we're going to do is for this budget and expenses data, we're going to be modifying that file rather than just variables inside of our program to make sure that these things stay persistent. So we're going to have a file path, which is just going to be a JSON file that's going to be saved in the same folder where our program is. We can call it whatever we want. We're just going to call it that. Then we're going to have this load budget data function. When this program runs, it's going to load data from this JSON file. So we're going to go ahead and make that. I'm going to def load budget data with the file path that we give it. Now, this might again be a new thing for you in Python, but it's very, very useful. And this is how can we write and read files inside of our Python program. The way we can do that is first of all, we go try. I'm going to explain in a second why we do that. And then this is the crucial line with open file path. And as a second argument, R, which refers to read. So we're telling this function open, which is the function that we're using to open up a file, that we're just like trying to read it. We're not trying to write it. If we were trying to write it, we might apply it with W. And if you hover over it, it's going to give us all the options. Over there, it defaults to R, which means open for reading in text mode. Other command values are W for writing, X for creating and writing a new file, and blah, blah, blah. And you can read that for further details. And then we go as file. So now this file variable is going to give us access to this file inside of our Python program. With this line, we have now opened up this file for our Python program to read it and like access the details and things like this. So we're going to need to run something called data, which is going to be equal to JSON, not JSON, JSON dot loads file. And JSON is going to be another package, so a library that we're going to have to import just like that. That gives us access to different tools to read JSON files. And now after that, we're going to return data. And from the data, we're going to grab initial underscore budget. And we're going to grab data expenses just like this. And this is just the form in which we are simply deciding that we're going to store this stuff inside of these files. And of course, this should be R, just like this. But whenever we're doing anything with files, like we're trying to read files, we need to account for the case where we might have an error here. So if an error happens when we run these files, we're going to run into something called an exception. So we're going to catch that exception to make sure our program doesn't crash using this except line at the end. Instead of it, we're putting the potential errors we might get. And if that happens, we're returning 0 and an empty list back into our program to basically indicate that there was nothing inside. And one more thing, there is a typo right there. It should be JSON load, not JSON loads, just like that. So that means we no longer need this line because we're actually getting the initial file from inside of this file. And if the file doesn't exist, I'll show you how we fix that in a moment. Okay, so we're halfway there. We're correctly getting the data from the file if the file exists. But what we also need to do is when we are exiting the program, we need to make sure that the current stuff that is just stored in variables inside of our program is now then saved back in that file. And so instead of this choice 3, which is going to be to exit the application, we're going to need to call something called save budget details, or however you want to call it, with the file path initial underscore budget as well as expenses. And we'll implement that in a moment. The other thing we need to do is make sure that if nothing comes out of here, we need to give ourselves the initial budget. So if the initial budget is 0, we need to get it, which we do like this. So we go if initial budget is 0, then we ask for it from the user as we did before. And these expenses, obviously it does not need to be initialized because it's either going to be empty when it comes from the file or doesn't come back whether it exists or not. And if it doesn't exist, it's going to come back as empty anyway. So now last things last, save budget details is going to be a function that is still need to be implemented. We're gonna define it just like this, taking in file path, initial budget and expenses. So what we're gonna do is define a data object, which is then gonna go inside of this file, which we're gonna save. We're gonna again use this syntax to open up a file. This time we're gonna be using a different flag to indicate that we are actually creating or writing into a file using this W like this. And as file, again, this file is now gonna be this file, which we are either creating or modifying depending on whether it exists or not. And by the way, this thing does it automatically. So then we go JSON dumps, or no, dumps, not dumps, dump. So JSON dump is a function to essentially just dump this data object into this file that we are creating. So we're giving data as the first argument, which is the thing to be dumped into that file. And then we're getting the file, which is this file that we are opening up over here. And we're giving something called an indent to like basically make it nicer to look at. We'll see in a second why we do that. So that should cover it. Okay, so I'm not entirely sure if I've done everything correctly here, but usually in these cases, it's best to just test out your program. And your program is just gonna tell you if something is wrong. It's much faster than trying to like read through everything and see if I've made something wrong somewhere. So I'm gonna start this. Welcome to the budget app. Please enter your initial budget. So in this case, we didn't have this file yet. So this came out empty. Initial budget came out as 0. So it's asking for us. This if condition was triggered. So we're giving us $1,000 this time. Now, what would you like to do? Add an expense, just like this. Groceries of $100. Another expense, dinner of $50, like this. I'm gonna show budget details. Okay, expenses, total spend, budget left. Now let's see if this works. I'm gonna put 3 to exit the program. Okay, trace back. We made a mistake somewhere. Blah 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 is not supported between instances of float and list. Okay, so we can see that on line 64 is where our error happened last. Save budget details. Okay, it looks like it's just a typo, or yeah, indeed. Whoopsie, it should be a comma, of course. Let's try this again. That didn't work, so the file now doesn't exist because we had an error last time. Now we're gonna just add an expense of groceries. I'll type 100. Okay, I'm just gonna test it out again. 3. Indeed, it looks like it worked this time. If you look closely, inside of our folder is now created a JSON file with the extension .json. If we click it open, we can see that this data is now inside of this file. How awesome. We have an initial budget, which was the initial budget. And so now, if I run this program again, budget tracker, and I go and show budget details without adding anything, then we can see that we still have these expenses as well as our total spend and our remaining budget, because it's being stored persistently inside of this JSON file rather than just inside of our program. This is the key insight here. This is a super important thing. Now, obviously, it's going to be a much more complicated and sophisticated database solutions that you can make with like SQLite and like different database languages. Now that is what you want to do perhaps at the next level of your programming journey. But this right here is the most simple way for you to essentially create a database where you can store data on your computer persistently, very simply using these JSON files. And you'll be surprised, like in the real world, just how complicated things are just stored in this simple JSON file. In a lot of our startup coding, for example, we literally stored like pretty complex ass data just in JSON files using these JSON libraries in, well, we were using JavaScript, but anyway, same principle. Very easy to use, so a very good skill to have as a programmer. And now we have a budgeting tracker. Now obviously you can take this and make it more complex, allow different things like different commands, and maybe you can even make a visual user interface for this. Like, this is a really cool program that you can definitely work on. With that though, let's move on to the next one, which is going to be a language learning app. Now this is pretty cool, which I know I'm saying about every project, but this is particularly cool because I think it's quite unique. I haven't anyone on YouTube seen do a program like this in Python. So we're gonna create language _learning app.py. So when I was younger, I was really into learning languages. I still would be, but nowadays I'm more into learning programming languages rather than human languages. But what I learned about language learning is that in the beginning, the most high ROI thing you can do is just take a list of like the most common 100 or 1,000 words in that language and then just practice those words over and over, because you might be surprised to hear that, like, I think the statistic is like 80% of any given language is just made up of the most common 1,000 words. So if you can study the most common 1,000 words, you're literally going to understand like 80% of that language. So what you can do is you can go to ChatGPT right here, and you might have to try a couple of times to get it to give it to you in the proper format. But let's say you want to learn Spanish. You're going to tell it, can you give me the most common 100 words in Spanish with English translations? Please give as a Python object. Let's see if this works. It's going to give me common Spanish words. It's going to give it as an object. Now that's one way of getting it. The way I got it before was in format that I slightly prefer, which is going to be like this, which is going to have a words list where every item of the list is going to be an object with the attribute Spanish and the attribute English. I just prefer it simply because this allows us to practice them in both kinds of ways. We'll see in a moment how this works. But now let's get into the actual app. So first, again, we're going to start off with the main program that's going to run, which is going to print something like welcome to the language learning app, and input, which is going to please enter to start the quiz, just to prompt the user to start the game. And then we're going to have this quiz user function, which is going to be the main thing that we're mainly running here. So def quiz user with a words list that it takes in that allows us to use different lists of words. This is just, I think, like 30 or something. Now there's many ways to do this, and this implementation here is not going to be the most optimal way to learn, but you can take this and modify it. But we're just going to first go to this random library again, which we are of course going to have to import, and we're going to go and do a random shuffle of these words, which is going to just take this words list and just shuffle them randomly, so we don't know in which order we're going to get them. Then we're going to give ourselves a score, and then we're going to loop over this list of words, so word in words. So just at the same time, I'm just going to print that. So it's the same time, I'm going to copy paste. So first we're going to print what is the English translation of word Spanish. So it's going to take the word and the Spanish version of it. Then we're going to get the answer from the user, and we're going to call two string methods. First is the lower. So if we, for whatever reason, have caps lock on or something, that's not going to affect the answer. Just going to put everything into lowercase, because everything here is going to be lowercase as well. And we're also going to strip. So for example, if we're being careless and we're adding like white spaces, those are not going to affect our answer either. So as you can see, if we hover over it, return a copy of the string with the leading and trailing white space removed. So that's what we're doing. Then we're going to get the correct answer, which is going to be the word English attribute. Again, we're going to put it into lower just in case something here happens to have uppercase for whatever reason. Then we're going to compare if user answer is equal to correct answer. Then we're going to print correct, amazing, as well as and empty line, and we're going to append our score by 1 like that. And in the else case, we're going to print wrong, idiot, and the correct answer is that. And at the end, we're just gonna print the score. Now this is not gonna be optimal just yet. In reality, you might wanna do what's called like space repetition. So based on when was the last time you saw these words, you might wanna like space them out a bit further or a bit closer, and based on whether you got them correct or not, you might wanna like give some like additional attributes here, like last seen, or to indicate like whether last time we saw this word, it was correct or not. But just to illustrate this to you, this is how we're going to do this. So we're gonna run this program, and we're gonna enter the star. What is the English translation of le? Well, it's gonna be slightly suboptimal because I'm gonna say 2. Well, okay, that was wrong anyway. L is gonna be the. Correct. What is the English translation of para? That is 4, right? No. Well, again, this right here is again not optimal because I gave 4 and the correct answer is 4/2. So you might want to implement some sort of logic, but the English translation is perhaps a list of and from, and then what it does is that it will check through all of these, and it will check if your answer is one of the items on this list. Now that's going to be a much better way to do this, but I'm going to leave that to you as an exercise. E is going to be, no, that's going to be and, right? Just like this. I'm pretty good at Spanish. That's whatever. Im de of C. Damn it. Who? Anyway, you get the point. This is pretty cool if I say so myself. But yeah, let's move on to the last one, which is going to be probably the most complex, perhaps, but nothing we can't handle. Let's take a look. It's going to be a desktop cleaner. So the idea of this program is that, let's say we have our desktop folder that looks like this, that's messy with all kinds of different files. What we might want to do is just run one program, which I'm going to do right now, and boom, have everything sorted into different folders based on the file type. Nicely sorted, just like that. Now, how might we do this? Well, for this purpose, we're going to need two libraries that we're going to have to import. We're going to have to import OS, which essentially gives us access to a lot of like operating system level like things that we can do to our computer, as well as shuttle, which is like a library that allows us to move files inside of our computer's file system. By the way, I have a full video where I make a slightly more complex version of this on my channel. You can click on it down below in the description. By the way, I also have a full playlist of Python programs if you're interested in more stuff. Again, link down below. Alongside my full program, if you want to learn Python from scratch and become a developer, also link down below. But what are we doing? Well, this is going to be the main run. We're going to run that this script is running. We're going to get a folder path. Now, this folder path is going to be something that you're going to have to define for yourself, like whatever is the full path to the actual downloads folder on your computer. The way you can get that is if you open up your terminal on your computer, and this is on Mac. On Windows is probably slightly similar, but you can just Google how to do this. So we're going to go and we're going to see to the downloads folder. So CD means change directory. So we're changing directory to the actual downloads folder. And then we're typing in pwd, which stands for present working directory. And it's going to print us the actual path, the downloads folder. So you can just get that, copy it into this string folder path right here. So then we're going to check os.path.isdir. And the purpose of this is just to validate this is an actual directory, whether this actually is a directory. And if so, it's going to run this clean folder function, which again, we're going to define in a second. And then it's going to print clean incomplete. Else it's going to tell us that it was an invalid folder path and that we were naughty and stupid, basically. So we're going to define clean folder with the folder path. Now, what we're going to do is go for file name in os.listdir folder path. By the way, if you're wondering how the hell do I know all of these functions from all of these libraries? Well, I don't. When I was doing these, I just took this OS library and I went on Google and I typed in OS library documentation, where you see like a documentation of all the different operations and functions that you have access to. And this particular one, if you hover over it, it will tell you, well, actually it doesn't, because this documentation sucks. But if you read it from the documentation, it will tell you that this simply gives us access to a list of all of the files inside of this folder that we're giving to this function. And actually, well, pro tip, much easier way to do this is just to tell ChatGPT, and it's gonna probably suggest something. There's probably other ways of doing this as well. There you go. It's giving us the OS library, and there you go. That is it. And it's also, well, it's slightly different syntax, but same thing. Anyway, now we have access to every file inside of that directory. What are we going to do with every file? Well, first we have to validate that that actually is a valid file in a way. So we're going to do that by going os.path.isFile. So similarly, before we checked isdir to validate that it's a proper directory. Now we're validating that it's a proper file. And now we're actually going to need the full file path, which is going to be this file name with the path of the folder in which it is inside. And so we get that full path with this os.path.join folder path, which is the path of the folder with the file name. So this is just literally joining these two things, the folder path with the file path, to get the full path to the actual folder. And so just to see where we are right now, I'm just gonna print, well, I'm actually just gonna print this to show you what we are getting. Colon, what is wrong, what is wrong, what is wrong? Of course, there is one more, there is one too many of those. Okay, let's see. We're gonna run that. Okay, so we get a list of all of the files that are inside of our downloads folder, which if we open it up, we see that that is indeed what it is, just like that. Next thing, so what do we need to do? We need to start making subfolders per the file extension. Of course, there's many different ways to do this. In my other video, I do this in a more complicated way, to do it by like different images and or videos or documents and things like this. But we're just gonna need to access the file extension from every file. So we're gonna use a bit of trickery to do that. We're gonna get a variable called file extension by going file name dot split. So we're splitting it by dot because we know that the file extension is gonna come after the final dot inside of that string. And then by indexing with -1, we get the last thing that is coming out. So file name dot split is gonna give us a list of substrings that are split by the dot. And we know that the last one of those is going to be the file extension. By indexing with -1, we get the last one, because -1 indexing gives us the final one. And then we're going to go dot lower to make sure that everything is in lower case. We're going to make sure that as long as it exists, we're going to make a name for this new subfolder that we're going to start creating, which is going to be an F string with the file extension name in uppercase, then space files. That's just going to be the name. So for example, if we have a PNG file, then the name of the folder where that file is going to go is going to be PNG in uppercase space files. You can of course name this in whatever way you please. Then we're going to need to get a subfolder path. Obviously in the beginning, that subfolder, now obviously we have sort of two cases here. The subfolder might already exist if in the previous iteration that subfolder has already been created, or it might not exist. So we're going to need to create a new function called create subfolder if needed. But basically it's going to take a folder underscore path as well as a subfolder name, and it's either going to go ahead and create that subfolder and then return as the path, or just return as the path if it already exists. So first we're gonna check if this subfolder path already exists. So it's gonna go os path join. It's gonna take the folder path as well as the subfolder name. So it's gonna give us that path, and then we're gonna use this check to say if not os.path.exists. So this again, which you would just get from ChatGPT or in the documentation, will give us either true or false depending on if this subfolder path is already a real folder. And if not, we're gonna go and call os.makeDirs with this subfolder path. And this function is going to simply create a new subfolder with this path. And then after that, we're gonna return the subfolder path. And of course, if it already exists, then this line is not going to run and the path is simply going to be returned, which means that back in our function, we can just access the subfolder path, which is going to be returned by this create subfolder if needed function, which now we know that it will exist. Then we're going to need to get a file path, which is going to be again os path join with the folder path as well as the file name. And then finally, we're simply going to have to move that file with this file path to this subfolder path, for which we are going to make use of our shuttle library, which we imported here. And from ChatGPT or the documentation of this library, you would find that there is a method called move, so shuttle.move, where the first argument is the file that we're moving. Second argument is the folder to which we're moving it. And that is going to move our file correctly. And at the end, we're just going to print moved file name to subfolder name, just like this. I feel like this should work. Let's try it. So we're going to have our current downloads, which is going to be a bit messy. We're going to run this and we get errors. Oh no. Okay. Destination path already exists. Okay. So what we're going to do is be a bit lazy and we're just going to ask ChatGPT for help. And I'm showing this to you because this is legitimately what I would do. If for like within a few seconds, I don't know what to do, it's usually just easier to ask ChatGPT, because ChatGPT is just a genius, and why waste brain power if you can just get it to fix it? Obviously understand what the problem is after it gives it to you, because that is how you learn, but use these AI tools. I use them all the time. Everyone uses them. Don't be afraid of using them. Okay, so this is the line that we're going to have to add. It's going to come off the file path. New location. Okay, so we're first going to get the new location, which is where that file would go, I suppose. And then we first check if it already exists over there. Then we're going to move it. Otherwise, we're going to skip this. And we're going to see if this works now. Of course, it doesn't. And of course, this can now be removed. And now things seem to have worked. Let's open up our downloads, and beautiful. Everything is beautifully organized in 2 folders. So that is the final project. I hope you enjoyed this video. I hope at least one of these projects was interesting to you. We are going to be using a Python library called Selenium to essentially create a bot to swipe and find matches for you automatically. We're also going to be able to message all of your matches, so you don't need to spend time like figuring out what to say and like, whoa, like swiping on Tinder, even if you don't care about using Tinder. This project is really going to be amazing for you because you are going to learn how to do web scraping on Python, which is a really awesome and interesting thing to have. And as I always say, the best way to learn things is to build something interesting. And we are going to see if I can actually get a date automatically using Python. So if you're excited for that, before we start, go down there and hit the like button down below in the description. It's completely free to do, and it is all I ask from you in return for me creating these videos for you to watch for free. So here is a picture of a cute puppy. as a thank you and a sign of appreciation for you hitting that like button. Okay, open up your favorite code file and it is time to find some love using Python. We only have to install two things. We have to install the Selenium Python library, which allows you to access essentially a web browser simply through your Python code automatically. And then we need to install this thing called a Chrome driver, which allows us to do these things in Chrome. If you want to follow exactly what we do here, download the Chrome driver and we'll be using Chrome. So you're going to select the latest stable release and then whatever operating system you have, basically download that, then unzip it. I'm not going to do it because I've already done it. You're going to go into the root directory of your computer. If you're on a Mac, you're basically going to go here and you're going to go Command Shift period to show the hidden files in your main folder, and then you're going to find this folder called user, and then local and bin. And you're basically going to move this Chrome driver file, which you downloaded before, into this specific folder right here. Then the only other thing you need to do is to open your code file and go pip install Selenium. Now we can start coding by going from Selenium import web driver. And then we'll also import sleep from time, and in a second you'll see exactly why. We're going to create a class called Tinderbot, and we're going to create an init function. This init function is what's going to automatically run whenever you initialize an instance of this Tinderbot class. We're going to initialize a driver with self.driver equals driver, which we just imported, dot Chrome. Essentially, this is going to initialize a Chrome driver, which we can now control using a Python code. And then we're going to start off with a function called open Tinder. Just as a test, we're first going to open up the Tinder website by going self.driver.get. And now when we run this tinderbot.py, we should open up a Chrome window. It's pretty cool. And now we can start doing things with it. So let me just show you exactly the workflow that we want to do. First, we want to be able to click this login button. Then we want to go to login with Facebook. And then we want to automatically first click off this window right here by clicking this button right here. Then enter our email and our password to log into Tinder. That's the first step. If you go right here on this window and you right click on whichever element you want your code to click, you can go inspect. It's going to show you the code for the HTML element that we want to find. The way we do that is we go copy full XPath. First, we're going to sleep for 2 seconds, simply because it takes time for the browser to load, simply because of internet speeds. It goes self.driver find element, and there's multiple ways in which you can find this element. I found the easiest way to do this is just by XPath, and then copy the XPath which we just got from the page. And then now we have this login button, which we found, this login button, saved as this variable right here in Python. And the way we click it, if we go login.click. So let's see if this actually works, or if I made any errors. Wouldn't be surprised if I have. And now we go here and look at that. It's automatically, I didn't do anything. It's automatically gone out there and clicked the button for us. And now basically all we're going to be doing is finding the things that we want to do and then adding them to our code file sequentially like this. Like again, we're going to go inspect on this login with Facebook button. Before we do this, you need to go to your Facebook settings and disable multi-factor authentication. You would do that, you would go to this button, again copy full XPath, go back to your code file. Actually, we're going to define a separate function for this, which is Facebook login. Basically, we're just doing the same thing. We're saving the login with Facebook button as a variable. We're using the XPath, which we copied, and then we're clicking it to see what happens. Before doing this, we're again sleeping for I think 1 second should be fine. And then we're running this Facebook login and we'll see if that works. I think it's opening up. It's clicked on that and it's clicked on the Facebook button. And we open up this window right here. This has now introduced a problem because it opens up this second window, but it doesn't work because actually what our code is still doing, it's focused on this main Tinder window right here. So what we want to do is focus on the new Facebook pop-up that has popped up. Basically, I'm just gonna paste the code here and explain to you what it does. So again, we're sleeping for 2 seconds here just to let it load before we do anything. Then we need to access the new window that we just opened. And luckily in our driver, we have this object called window handle. The base window right here, which is the Tinder window, that's the first one. So that'll be the first one in the list. As the second element of this list, we will have the Facebook pop-up window. And then we're gonna use self.driver facebook.switch2.window and then put the window that we want to switch to as an argument. This now switches our driver to the new Facebook pop-up window so that we can access it. And as you can see, we get this annoying allow the cookies from Facebook blah 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 pop up on top of this pop-up, but this is actually part of the same pop-up window. I hope that makes sense. So we can actually just again go here, inspect by the button element, copy full XPath, go back to a code, put the XPath here and then click it, which will essentially then click this button right here to only allow essential cookies, and then we can actually start entering our details. And for this, what we want to do here is create a separate file called login_details.py. Inside of here, you want to create two variables. So essentially, you want to copy down your Facebook email and your Facebook password into this separate file right here. And then in your main function, so this will import the email and password to you so that you don't have to show it in your actual code. Then in your Facebook login function, you would enter these lines right here. We're going to find the email field and the password, inspect, blah, blah, blah. You already know how to do this, okay? And same for the login button, which is this one, which you want to click after you've entered your details in here. Then the way you enter details into these text fields using Python is by going email field dot send underscore keys, and the same one for the password fields. And then after that, we finally switch to the main window to get back to the main Tinder window from a pop-up. So let's run our code right here. It's going to open up the pop-up. It's going to close, essentially switch back to the Tinder window. Voila, we have now logged into Tinder using a Python code. How cool is that? If you find it that cool, hit the like button down below and let's keep going. Now, the next thing that happens, at least for me, is that there's these two annoying pop-ups up here. There's this one, which we want to click out of, and then this one, we want to write into our code a way to get rid of this pop-up. So we can just minimize that, and once you run that, you already know how to do this. I'm not going to bore you with all the details, and essentially sometimes I found that these pop-ups weren't actually showing up, and then when it was finding it, it was sort of failing. So that's why I put these inside of these try except blocks. So this is for the first pop-up. We try to find this allow location button. If we find it, we click out of the notification. If we don't find it, essentially if the pop-up doesn't pop up for some reason, the program is not gonna crash because we have this except block where we just essentially print no location pop-up, and we do the same thing for the notifications pop-up. The next thing we wanna do is figure out how to actually like these profiles right here. So essentially, again, we want to find this like right swipe button right here, inspect, find XPath, blah, blah, blah. You already know how to do this. Essentially tell the program to just keep swiping right. Okay, editing me here. I actually ended up running into a lot of issues trying to do the liking by actually selecting the like button. So I thought I'd just cut straight into the part when later on in the video, I was going to fix this by doing it in a different way. So in the next section, if you see some code which we haven't done yet, just don't worry about it. Another way to like a person on Tinder is just to click the right arrow key, as you can see right here down here. So if you just select that and you keep pressing the right arrow key, it's just gonna keep liking, right? And it turned out that when you do this, you don't even need to click out of this pop-up. When these pop-ups come up, the like machine behind it would just keep on going. So this is the crucial change I made. In the right swipe function, I would just select the whole document by using the whole body documents XPath, and then keys dot arrow right. And to access that, you need to add this one more import line, so you can actually send just key presses in your window. The way we ended up doing the auto swipe function is that we create an infinite loop. Essentially every time we first sleep for, I think 4 seconds is excessive, 2 seconds is probably fine, and then we try to right swipe, which we do in the way that we just described. And then if that doesn't work, that means that there must be a match, and then we've created this close match function where we found the XPath of the button that you need to click to close out of a match to allow us to keep swiping. And then essentially it's just going to keep running, and it's going to keep swiping and swiping and swiping. At the end of the video, I actually show you this in action. It's pretty cool. Our next challenge is to figure out, because you know, when you're as attractive as me, you get all these matches right here, and I don't have time to message all of them individually. Ain't no one got time for that. Basically what we're gonna do is simply message all of them, and then out of those, the ones who actually end up replying, we can actually invest some time into. So to do that is actually not as simple, because we essentially somehow need to be able to loop over all of these matches right here. The way we would do that is we first need to find this parent element where all of these matches are located. And then we need to find each of these match boxes right here and add them into a list that we can then loop over. Essentially the element where all of these are stored, I believe, is this one right here. And then inside of there, these actual boxes of matches are part of these nested divs. And then inside of these, we have this A element with links to all of your matches. There's some things that we have in common here. For example, all of these have the class of match list item. And it turns out that in Python and Selenium, you don't have to use XPath, which is unique to every single element. What we can also do is find elements by putting an S there using class name. Basically using this, we can find all the tags with the class of match list item, which will be all of your matches. But there's a caveat here because this will also give you this box right here, which is the like sent, and this one, which is all your likes. We will find that this one also has an href of my likes, so we can basically differentiate out of this. So the way I've done this is essentially go all the matches. I'm just printing it to test it. Then when we want to go and message these matches, what we want to do is get this href tag over here and open this one, because this is actually the window where you'll be able to message someone. For profile in match profiles, if the href of the tag is this my likes one, we ignore it because that's not one of the matches. But if it's not, to this message links list, we will then append the profile.get_attribute of the href, which is the link that we will then want to access. And then we will create this in yet another function called send messages to matches. And then for all of these links, we're going to create this self.sendMessage function. So we'll define this function def send message. And first we will need to get a new window with the same way as we opened Tinder up here in the beginning. So we'll just copy that. So self.driver.get, and instead of this main Tinder link, so for all of these links in this links list, we're running this function right here. First we're opening the window. What you will see is that there is this text box, which we will first need to find, again using inspect. We found just like this. And after that, if you remember from the past how we actually input text into a text area, text area.send keys, and then we need to send off a very intelligent, high response rate message to send to all of our matches, basically. So hi, all we have to do, find this send button, copy full XPath, just like that. And when you run this function, when you run all of this, it's going to automatically send this highly valuable, amazing opening message to all of your matches. So now the moment of truth, let's try this thing. What am I doing? Oh my god. You know, I didn't actually try this part beforehand because I didn't want to like send all my messages, but literally, oh my god. Well, it's working. Voila, amazing. We've now sent all of these messages just using Python. Now, all that's missing is my sex appeal. In this video, I'm gonna show you how I coded a Python bot to literally find me an apartment in the city where I live in at a really good price. What we will be using is something called web scraping, which is a skill that I think every programmer should learn because it is so versatile and allows you to build so many amazing and useful projects that you can either number one, put on your portfolio and help you land a job, or number two, even build a profitable full-scale business around the project. What we will be learning today is number one, how to get started with web scraping even if you're a complete beginner, the full project of how I use web scraping using Python to automate my process of finding an apartment to live in, including a full tutorial of the project for complete beginners, and the full code will also be down below in the description. And number three, how to overcome the most common problems that you will eventually run into when you are web scraping, because the thing that you might not realize is that a lot of websites don't actually like it if you are using a Python bot to scrape them. So we'll be learning a very easy method to get over all these problems very quickly. So with that said, let's talk about web scraping. So if you don't know what web scraping is, if you're not aware of it, then I'm just going to briefly explain this to you. If you already know what web scraping is, you can go into this timestamp down below. So what web scraping essentially means is that, let's say you're opening up a web browser and you're opening up any website you want to go into, like let's say Amazon or Airbnb or wherever you're going. What web scraping simply means is that we're doing that same process of opening up a web browser on some web page, except we're doing it using code. So we're essentially creating like a small Python bot that is going to go to the internet on your behalf. So in many cases, let's say, for example, in this tutorial, we want to find some information about a bunch of apartments in whatever city you live in. Instead of going there manually and like manually writing out and copying the different apartments and the prices and things like this, we can simply send this Python bot and instruct it to look at the web page and only extract the information that we're interested in, and then return that information for us for further processing, so we can do whatever we as humans want to do with it, so we don't need to spend the time to manually do all this data gathering. It's very, very common for any tasks like this where we want to extract a bunch of information from the internet. Like you could think of extracting job postings or like e-commerce data or whatever you're interested in. Where doing all of that manually would be either cumbersome or it would just take a bunch of time basically. So now I'm going to show you how you can easily get started with web scraping. Then we'll go over some of the problems, how to overcome them, and finally we'll build this full project. So to get started with web scraping, what you're going to need to do is install two packages, just two packages that you're going to need. And you're going to do it using a command like this: pip install requests and beautiful soup 4. So requests is a library that simply allows us to access the internet directly using Python, and beautiful soup is a library that actually allows us to then interact with these actual HTML web pages using our code very, very easily. So you're going to run this command, you're going to install them. I've already installed them, so it's not actually going to do anything. But then what you're going to do is import both of these. We're going to import requests, and the way you're going to import the other one is from BS4. You're going to go import beautiful soup. And I think the first B has to be capitalized just like this. Now, to actually access the internet using Python, this is going to be very simple. You're going to simply create a variable called URL where you're going to paste as a string the URL where you essentially want to send your Python bot. In this particular video, we're going to be using this website called The Blue Ground. It's essentially like a platform where you can find a lot of furnished short-term rentals in a lot of places in the world. So you're going to go here and look at the city that you're interested in. For the purposes of this example, we're going to use Dubai because Dubai is where I live. And you're going to search this up and you're going to copy this URL from up here, and you're going to go and save it as a variable in your Python code. Then you're going to create another variable called response that is going to equal request.get, where the first parameter is going to be the URL that you want to use. And that's really it for now. And now what you're going to be able to do is simply print this response to see if we are able to access this website successfully. So we're going to run that, and what we're going to get is something like this. It said response 200. 200 in the case of web requests in programming essentially means a successful response. And we don't see the website yet, but we see that we were successfully able to send a GET request to get the contents of this web page using Python code. Now, to actually see the contents of this web page, we're going to use this other library. And to do that, we're going to create yet another variable called soup that's going to be equal to beautiful soup, and as the first parameter we're going to say response.text, and as the second one we're going to need to define essentially how we want to parse this HTML that's going to come back, and we're going to say html.parser. And now what we're going to do is, then instead of printing this response, we're going to print soup. And what beautiful soup is essentially going to do is going to take that web page and essentially parse it for us in a format that now we can start searching up things from this. Essentially what we got is basically the entire HTML of the website that we're looking at, and from there we can now start extracting the exact data that we're looking for. But before we move on to the actual project, there's a couple of issues that you're going to run into essentially every time you do this web scraping. For example, a lot of websites don't really like seeing their websites being scraped by bots. They want to only see human traffic going into their websites. So what's going to happen a lot of the time is that you'll build an amazing web scraper, you use it a bit of time, but then it's going to end up being blocked by the website because they see that the same IP address, and IP address is essentially like the computer world address of your computer, where every time you request something from a website, they can see the IP address where that request is coming from. If the same IP address is used too many times, the site is going to detect like, okay, that must be a bot, because a real human wouldn't do like 100 requests in a minute or something like that. Another thing that might happen is that there might be what's called captchas. So you might have seen many times when you go to a website, they have this little captcha where you need to like type out some numbers from a picture or something to essentially show the website that you're not a bot. You might have geo restrictions as well. Some websites might not be available in your country. So all of these are very common problems they're going to run into when you are doing web scraping. And one common solution to a lot of these problems is to use what's called a proxy server. So what a proxy is essentially like a thing in between you and the website that you're trying to access. And what that proxy will do will essentially bypass these captchas, and you can set these proxies to be physically located in wherever you want. So let's say some website is only available in Canada, you can set the proxy to have an IP address in Canada so that your target website thinks that your request is coming from Canada. And to prevent the IP address blocking, what these proxies can then do is essentially rotate your IP address so that with every request that you're sending, the proxy server is going to have a different IP address. Now all of this probably sounds very complicated, and you might already be like, I don't want to do web scraping at all. Well, you don't have to be worried, because there's actually a very easy solution to this, because what you can use is a service called Data Impulse. Now, Data Impulse, who are very kindly sponsoring this video as well, essentially provide you access to ready-made proxies that you can then use directly in your web scraping projects. All you need to do is use Data Impulse, put their proxy in between your request and your target website, and I'll show you how to do that in just a few lines of code in a second. And then you essentially just automatically bypass all of these problems that I just described. What you're going to do is go to dataimpulse.com and you're going to click on Try Now. And then what's going to happen is that you're going to create an account, and once you go through the process, you're going to see a dashboard like this, where then you're going to add a plan for the type of proxy that you want to use. And once you go in here, you're going to be able to see this proxy access box at the top left. Keep this in mind because we'll need a couple of details from here in a second. You're going to see your usage and how you can add gigabytes for you to use. Then you're going to have a proxy configuration where you're going to essentially choose the countries from which these IP addresses are going to be sourced from. I've just chosen a couple of countries here for example purposes. You can choose the interval at which these IP addresses are going to be rotated, whether you only want anonymous proxies and things like this. And there's a couple of other settings that you can set here. And then what you can do is you can go to these tutorials site on the Data Impulse website. That's going to have a bunch of easy to use tutorials for whatever you're using to use your web scraper. What we are using is Python requests. So we're just going to find Python requests from here. We're going to click on learn more, and it's just going to give you a couple of lines of code that you're going to want to copy into your project to add these proxies to your project automatically. So what we're going to do is go in here, copy paste these, and you're going to have these two in here that you're going to need to fill: your proxy login and your proxy password. And you're going to find these from your Data Impulse dashboard from this top left hand corner up here. I'm not going to show you mine for obvious reasons, so you don't steal my stuff, but you would fill this in, and then the only thing you need to do is on this line right here where you're sending the request to the server, you're going to need to add one more parameter, which is going to be proxies, which is going to be equal to proxies, which is going to be this object here that we have created. So this takes care of all of that for us. Now we have this proxy infrastructure in between us and the target website automatically, and that is just everything that you need to do. You don't need to worry about anything else. Pretty neat and very easy. Now to continue on with our project, we're gonna go back to our website in here, and we need to now think about what is the data that we actually want to access from this site. So what we can see here is that we have a bunch of these different apartments, and what we would probably like is to get the name of the apartment, like the building name and things like this, plus the price. And what I'd probably want to do is only include apartments that are below a certain price. Let's say I have a budget and I don't want to scroll through all of these. Now I know obviously I could do this using these filters in here, but let's say like every day I want to be able to check whether there are new apartments available at my budget. I can set this so that my scraper will every day at a certain time find all the apartments, like all the new listings, for example, at a certain price, and then send them to me as an email. So I don't have to manually go in here every single day. So the way we do that is we need to now look at the HTML of this page and figure out where are these elements that we're interested in. Specifically, for example, we're interested in all of these different cards. So what we're going to do is click on inspect, which you can do by left clicking and then going down here to inspect. And then we can see the entire HTML of this page. And from here, by hovering over these different elements, Chrome is going to show to us which element we are essentially hovering over. So if we go in here and we click inspect again, it's going to take us to these details. So the way this seems to work in here is that we have, for every one of these apartments, the top element is going to be this A tag in here that is going to have this href. And what we're going to look for is the class of this A tag. And what we can then do is copy this class name and using Beautiful Soup, essentially tell our Beautiful Soup to look at this soup, which is the entire HTML, and look for all of the A tags that have a class of property. Let's see how to do that. We can do something like this. For example, we're going to create an apartment list variable. It's going to be equal to soup.find all. So find all is going to be a method that is included in this Beautiful Soup library to find elements that we're looking for. And as the first parameter to this find all function, we're going to input the type of tag that we're looking for. We're looking for an A tag because this is an A tag. And then what we're looking for, and this is essentially the filter that we're using to essentially determine what kinds of A tags we're looking for. We're going to set it so that it has a class underscore equal to the class that we just copied, which is going to be property. So what this is going to do is return us a list of all of the A tags that it finds that match this condition. Then what we can do is run a for loop for apartment in apartment list. And we're just going to print all of them to make sure that this is working properly. And we're no longer going to print the entire soup. Now, once we run this, there seems to be a problem. Max retries, of course, because I forgot to actually add the proxy login and proxy password. I'm going to go and do that and then come back to you. All right, I've now gone ahead and copied those in. I'm not going to show them to you, but now it should work. Let's try that. And as you can see, we receive a list of a bunch of A tags that seem to be corresponding to all of these A tags in here that correspond to all of these apartments. So that is a great start. Now, what is the information that we're actually looking for all of these apartments? Well, we would want to find out the name in here. We'd want to find out the price and also probably the link so that I can just receive a list of all of these, and any of them that sound interesting to me, I can just click on the link directly to go into the listing. Well, the link is going to be the easiest because it is directly in this anchor tag in here with this href property. So what we can do using Beautiful Soup, there is another function called get, so which we can access by going apartment.get, and what we're getting is the href from this anchor tag, and we're going to save that as a URL variable right here. And it seems like the URL is only the specific endpoint to that apartment. So what we're going to want to do is also append to this URL the sort of root URL, theblueground.com right here. So it's going to be this plus URL. And now just to make sure that everything works correctly, we're just going to print URL like that. Would you look at that? We get a bunch of URLs right here. Now the next step is going to be to get the title and the price. The way we do that is using a slightly different function. So we're going to create a variable called price that is going to be equal to something called apartment. And we can't use get here because the price isn't directly included in this tag. What is actually included is in a child element of this A tag. So we're going to need to navigate all the way down until we find this price. So it looks like this price is included in, and we need to go quite far down here, is included in this element down here. So it's a span tag with a class of price amount. So what we can try to do, simply use this one, and it's we're going to use a function called find. So what we're looking for is a span, and now it's only looking for spans within this apartment tag in here. It's not looking at the entire document. It's only within this one. I hope there's only one, but we'll see. So I'm looking for a span with a class of this price amount. And notice here we're using find and not find all, because I'm anticipating that there is only one of them. If there's multiple that we're looking for, we would use find all. If we're only looking for one, then we use find. So let's see if this works. We're going to print price in here, and it looks like it indeed worked. We get the correct element. Now the last thing we need to do is actually get this price and not this entire element. And the way we do that is by then getting from the return value of this simply text, and we're just gonna strip like this. Now we're gonna run that again, and would you look at that, now we're getting all the prices. So in the same kind of way, we now want to find this name in here. So we're gonna hover over these until we find the place that we're looking for, and it looks like it also has the area and the name in separate ones, so that's pretty useful. So what we're gonna do is simply copy paste this twice and name this, let's call this building, because I think it's the building name, and then the area, and we're doing the exact same thing except using slightly different class names like that. And this one is property address like that, and we're gonna print building as well as area as well. Let's see if everything is working correctly, and it looks like it is. I'm quite surprised. Often there's quite a bit more problems than this when using web scraping. With that said, the last thing we now want to do is create probably another list called filtered apartments that is initialized as an empty list. And then at the end here, we're just gonna append a dictionary that has like URL, area, building, price, and we'll probably do this so that the price is a number, because this is actually taking it as a string. So the price is going to be price dot replace comma empty string to take away the comma, like for example right here, and then we're going to cast that to, let's say, float. That should work. End of all of this, we're simply going to print filtered apartments. Let's see if I made any mistakes. Looks like, oh, of course, because this has to be URL like this, area like this as a string. This one needs to come for that. Run it now. Now it looks like everything is working correctly. We're getting price as a float, amazing, just like that. And now we can actually do the filtering where we say if price, and actually we'll do this price conversion earlier than this. We'll say price is now equal to this, and we'll say if price is below, let's say, a budget, and we'll create a function, define get apartments, we'll get a budget, and now all of this will be inside of this function. We'll get a URL, that, and a budget, and now at the end we're gonna run get apartment with the URL and let's say a budget of 8,000, and this is dirhams, by the way, the UAE currency, not dollars, so you're gonna need to use the correct currency. So if price is less than budget, only then we add it to the filtered apartments, and then at the end we print them, and we also return filtered apartments. And there's a problem, except it's because I forgot to add the edited price in here. We'll do that, and would you look at that, now we are only getting apartments that are below my budget. Now we will actually leave this here, but if you want to see the absolute full project, then I have it here where actually I'm adding a ton more code to it. I'm adding here like an email function that is then sending it to me as an email every day. I'm scheduling it to happen once a day. I will leave this full project down below in the description, but I will actually leave it to you as a challenge to now expand this to whatever you want. Probably you're not going to be using the exact website that I am using because it's going to depend on your location, what you're looking for. So use this same idea in whatever website that you would use to look at apartments for either short term or long term of whatever you're renting, whatever location you're interested in, and then expand this a little bit. Schedule this to run every day, send the results to you as an email, and actually make this useful for you. I'm going to leave that to you. In this video, I'm going to show you how to make your first machine learning resume project from completely scratch with no previous experience with machine learning. All you're going to need to know to go through this video is basic understanding of Python and a willingness to learn. What we're going to be building is an email spam detector bot. Essentially, what this will allow you to do is give a bunch of emails with a bunch of text to our machine learning bot that will automatically detect whether that email is going to be spam or not spam. This is a really great beginner project that's going to allow us to learn about some of the basic machine learning concepts. It's going to allow us to learn some of the more popular machine learning libraries, how to generally get started with machine learning, and it is going to give you an interesting and impressive project for your portfolio at the end of it. So let us get started. But before we get into building the project, when you're building machine learning projects, there's going to be some issues that you're going to run into if you simply do all of this locally on your computer. Specifically, because with machine learning project, you're always using so many different libraries that are meant for machine learning. What's going to happen is that if you already have existing versions of these libraries on your computer, perhaps you're using them in a different project, you might run into what are called dependency conflicts, where there's conflicts between the different versions of these libraries on your computer. The second issue is if you want to run your machine learning project on a different computer later on, you might run into inconsistent behavior because of different operating systems, different install libraries, different configurations and things like this. And it's going to also be difficult to scale these applications unless you're using a tool like Docker, who is also the sponsor of today's video. Because using Docker is going to allow you to run your machine learning applications in what are called containers. You can think of a container as essentially like an isolated package that includes everything that you need to run a specific application, including all the code, all the packages with the correct versions, all the tools and configurations and everything else you need, which is why Docker is the industry standard way that machine learning applications are usually deployed. So what we're going to be doing in this video is building our project and then just with a couple of commands, deploying this project using Docker. And this is also great for you because as a professional developer, by the way, it's very, very likely that you're going to be using Docker. I had to use Docker at my software engineering job. So it's just a very good skill to learn on what Docker is and how to use it. So now let's get into building our project. All right, so welcome to the code. So the way this is going to happen on broad terms is that we're going to be training a machine learning model using this test dataset that we have found online on this URL, which is going to be left down below. Essentially what we have here is a bunch of text that is pre-labeled. What does this mean? It means that we already have labels for all of these emails, or actually in this case, these are just text messages, but it will serve the same purpose, where some of them are marked as spam and some of them are marked as ham. This is very common for pretty much any machine learning use case. We're going to need to give our machine learning model some pre-existing data where we already know whether they are spam or not spam, so that the model can essentially learn from this what attributes spam emails usually have, so that then we can give it text that is not labeled, and based on what it has learned from this dataset, it can accurately predict whether that message is spam or not. And the way this is going to work on broad terms, or very high level terms, is that we're going to feed all of this data to a machine learning model using a library called scikit-learn, a very, very common Python machine learning library. This essentially gives us a ton of tools to train a machine learning model. And the way that is going to happen is that it's essentially going to look at all of the words on all of these messages, and then it is going to learn which words are commonly inside of spam messages. And then when we give it any piece of text, it's going to look at all the words, and based on the words, it's going to predict, given that these specific words are present in the message, how likely is it that that email is spam. So to get started, what we're going to do is import pandas as PD. Pandas is essentially a data analysis library that we're going to use to import our data and deal with it. We're going to have a couple of functions here. First, we're just going to have a function for loading the data. And the way this is going to happen is we're going to have a URL that is going to be equal to this URL, to this data that we're using as test data over here. Then what we're going to do is go data is equal to pd.read_CSV, because this is actually what this is. This is a CSV file that we're simply obtaining from online. And we're getting that from this URL, and we need to define a separator, which is going to be something that looks a bit funny. It's going to be /t, that simply means a tab, because the label and the text is separated using a tab. So we're just defining that as the separator. Header as none, because it does not have any header, and names are going to be, so we're just defining names for these values on the left and these values on the right. We're just going to call the first one label and the second one text, like this. And then we're going to go and define data label such that we're mapping these values from these text values into numerical values. So what we want to do is whenever we see spam, it is going to be a 1, and whenever we see a ham, it is going to be a 0. So we're going to go data label dot map. So we're mapping from these values such that whenever we see a ham, we want to assign it to 0, and whenever we see a spam, we want to assign it 1. We close those, and then we simply return this data. This will give us a pandas data frame with all of this data such that whenever there is a ham, it is a 0, and whenever there is a spam, it is a 1. This just makes it easier for us to deal with this data later on. And then all the way at the bottom, we're going to define a main function. What this line here simply means, if you're not aware, is that whenever we are running this file, this is the function that is going to run by default. So we're going to define data to be load data, and then just print the data to see what we see. Run the file. It's going to take a moment to load, and just like that, we can see that we have this data frame that has labels and it has text. So the first one is just the number of the item, then we have a label 0 or 1, and then we have the text. So now we have successfully obtained the data. Then the bigger function is going to be train_model. This is going to be the function that takes in the data and actually trains our machine learning model. And this is where we're going to get serious. So we're going to first of all get X as data text and Y as data label. So we're just grabbing our data into these variables. So then what we're going to do is, first of all, we're going to use something called a vectorizer that we're going to import from scikit-learn, from sklearn.feature_extraction.text. We're going to import dfid vectorizer. And if we go and we go look at this inside of the scikit-learn documentation, what we will learn is that this is a library that allows us to convert a collection of raw documents to a matrix of dfidf features. What the hell does this mean? Well, if we ask ChatGPT to explain dfid vectorizer in layman's terms, essentially what this means is that dfidf stands for term frequency inverse document frequency. So essentially this is a way of measuring how important a word is in a document relative to a collection of documents. And if we break it down, if you have any sort of document, where document in our case will refer to one of these emails or text, the term frequency will measure how often a word appears in that document. For example, if the word money appears 3 times in a 100-word document, its term frequency, so how frequent it is in that document, is going to be 3%. Then inverse document frequency means, imagine we have a bunch of emails like we do. The inverse document frequency measures how unique a word is across all of these documents. And when we combine them, we multiply the two of them, and this score will tell us how important a word is in a specific document. It simply essentially gives us a numeric way of analyzing all these different words that we're going to use in a second when we train this model. So that is essentially what this is going to do. So we're going to use that by calling tfid vectorizer. And using this vectorizer, we're then going to call something called fit_transform, which is going to take the X data, and we're going to assign that back to X data. What this line does is actually uses this vectorizer to construct a matrix that looks like this, where every row in the matrix is going to represent one email, and then every element of that row, which is a list of numbers, represents the DF/IDF score of that word. All right, so now that we have this, and by the way, we'll learn in a second why all of this is useful. We're going to go back up top, and from sklearn.model_selection, we will import train test split. What this will do is essentially split our data into a training set and a testing split. What does this mean? Well, imagine we have all of our data. What we want to do is use around 80% of that dataset to train our model, and then 20% of the dataset to then test the accuracy of our model to see how well we actually trained our model. And I'll show you how we actually train it in a second. But first we need to do the split. So we're going to define a couple of variables: x train, x test, y train, and y test. They're going to be equal to train test split, where we give the data, which is x and y, and we give test underscore size. And by the way, you would just learn what all of these parameters are and what you're supposed to input from the scikit-learn documentation. I've already looked at it, so we don't need to do that again. And this is going to be the most important part of our training algorithm. We're going to need to understand which model or algorithm are we going to use to train this model. Now, this is where you would require some knowledge about machine learning. You would need to understand what kind of algorithms are out there. And you would need to know which one will be the best for training this particular model. In this case, what we're going to use is something called multinomial NB, which we're going to have to first import from sklearn.naive base. And the name of it is going to be multinomial NB. So the way this is going to happen is actually just extremely simple. We're just going to set model to be equal to multinomial NB, just like this. And so in terms of our code, this is all we have to do. So you'll find this in a lot of machine learning projects. The code itself can actually be extremely simple, because what we're simply using is pre-built models using Python that are already made for us using Python libraries. So this model is actually extremely complicated, but we don't have to build it manually from scratch using all kinds of fancy mathematics, because we already have access to it using scikit-learn, and we can simply use it. Where what you would need to do if you want to actually become a machine learning engineer is, of course, understand what happens behind the scenes in these models. But just to explain this briefly, what multinomial NB is what's called a naive Bayes classifier. And if we go through an example of how this roughly works behind the scenes, if we imagine a training data set that looks something like this, where we have these 3 texts and these 3 labels. What the model will do is that it will look through all of these words, and for every single word, it will calculate what's called a conditional probability of what is the probability that that word appears in an email, given that the email is spam. So this is what this means if you're familiar with probability. This is the probability that the word free appears in a text, given that the text is spam. So essentially, if we look at all of the texts that are spam and calculate what is the probability that the word free will appear. Well, the probability will be 50% because it will appear in one of the 2 spam emails. Then it will calculate the same conditional probability for the word free, given that the message is not spam. So it will look at the one message that is not spam and calculate what is the probability that that word will appear in that message. And in this case, it is 0 because it does not appear. And it will do that for all of the words. And then what it will do, based on all of these probabilities, is calculate the probability that any given message is spam given these particular words. And using something called Bayes' theorem, we know that this probability is the same thing as the overall probability of any given message being spam, which is going to be simply the proportion of spam emails relative to all of the emails, times the probability that we see the word free given that the message is spam, times the probability that we see the word money given that the message is spam, times the probability that we see the word now given that the message is spam. So this will give us the probability that this particular message is spam. And then we will do the same for not spam using the same formula. And then we will compare the 2 values and conclude that because the probability for spam is higher than not spam, the classifier will label the email as spam. This is a very, very high level overview of how this works, and it's much more complicated in our example because our training sets are bigger, but this is essentially how our algorithm works. So we have this model, we will call model.fit with x underscore train and y underscore train. And we will then get our prediction, y pred, by calling model.predict using x test data. And then we will get our accuracy from accuracy score, which is another thing that we're going to import from sklearn. This time from sklearn.metrics. That's y test and y pred like this. Then we'll get a report, which is classification report y test y pred. So we will compare the predicted value to the actual test value to see how accurate we are. Then we will simply return accuracy and report. And in our main function, we will then get the accuracy and report by running train model, and we will print the accuracy and the classification report as so. So let's see how we did. Run the model. We get an accuracy score of 94%, which is pretty good. That means that on average, from our testing data, the model predicted the spamminess or non-spamminess of the email accurately 94.79% of the time. Now, how can we use this model to actually predict outcomes for text data that is not labeled yet? To do that, we're going to have to import one more thing. That is going to be import joblib. What joblib is essentially just a tool that allows us to save many different big models or files, in this case our scikit-learn model, into this essentially database that allows us to use it in different files. So we're going to call joblib.dump, which will dump this model into a database that we're going to call spam detector model.pkl. That is just the extension that we have to give it. And we are also going to dump something else that we need, which is going to be the vectorizer. And we'll just call it spam detector vectorizer, just like this. And then what we have is this other script in here called predict.py. Just to save time, I'm not going to code this up from zero. You can just copy this down below. Essentially here we're importing joblib and sys model in Python. And we have a function for loading the model, which is going to call joblib.load. Just going to load this model that we created here, and we need to simply rename it to be accurate. And same for this. So we're loading these two things that we saved in our previous script. So what would happen is when we first run this script would run to actually train the model, and then every time after that, it would simply use this predict.py script to actually use our model to make predictions. And this simply returns the model and vectorizer. And then we have this predict script in here that takes in the model and vectorizer, uses the vectorizer using vectorizer.transform, that takes in some text that we have given to this predict function to basically just transform this text into these numerical values that we needed to give to our multinomial NB model. And then we get a prediction using model.predict using this transformed text, and it's going to return either 1 or 0, and then we return either spam or not spam based on that. So let's see how this could work. What we simply go is go Python predict.py, and we give it some text, hello world, like this. It's going to make a prediction that is going to fail for some reason. And of course, because when we trained this model, we didn't yet have these lines in here, so it hasn't yet been saved to the joblib. So we'll train this again. This time we get an accuracy of 95.78%, which is even better. So now we can run our prediction with this line, hello world, and we get this message is not spam, as it probably shouldn't be. So this is our project in all its simplicity. Obviously, there's a lot of complexity behind the scenes that we don't yet understand unless you're a machine learning expert. But this is just to show you how simple it can be to build a machine learning project using Python once you know which model to use. So the crucial thing here was to understand that we should use the TF-ID vectorizer to turn our text into numerical data, and that we should use the multinomial NB model. This is the crucial part of our machine learning, and understanding when to use what model and what tools to use and when is the crux of being a machine learning engineer, not necessarily understanding how to code these actual models that are very complicated behind the scenes. But there's one more thing we want to do, because as we can see, we have a lot of things we are importing into our project. And as we learned before, usually for projects like this, for machine learning projects, we want to be deploying this using Docker. That makes it easier to share, that makes the behavior more consistent across different machines and things like this. So let us see how we can do that. This is going to be very, very simple. To remind us, what we want to do is create a Docker image, which is essentially like a package that contains everything needed to run this code, including all the code for both of these files, as well as all the libraries with the correct versions and things like that. So to do that, we just have to create one more file that we're going to call a Docker file, just like this. And in here, we're essentially going to specify how we want this Docker image to be created. So for that, we're going to have to define what is called a base or a parent image. And that is going to be simply a base Python image in Docker. And the way we do that is we use the syntax that is specific to this Docker file. We define from Python : 3.8 to define the version of Python -slim. This is essentially a predefined Python image that include everything needed to run Python, because that is needed to run our code. Then we're going to define something called a working directory using workdir as /app. So this is just going to be the working directory inside of this container. And then we define what is going to go inside of this work directory by going copy dot to mean basically everything. So everything inside of this local folder that we're looking at right here. And first, we're just going to delete a couple of things that we don't need that I had created when I was testing this. Like this, we're going to copy dot into /app. So we copy everything from here into the working directory. Then what we need to do is run something. So we're going to run the command pip install --no -cache -dir pandas and scikit -learn. So essentially what we're telling us is we want to first install pandas and scikit-learn. And then we're simply going to define the default command that we're going to use to run when this container is launched. And that is going to be Python and spam _detector.py. So basically, whenever this container is launched, we want to run a command where the keywords are going to be Python and spam detector to essentially run the spam detector script, which, as we remember, will train our model. What we'll then do is run a terminal command. And before that, we want to have our Docker desktop running on our computer. So remember to just turn it on first. Like this, we're going to run docker build -t spam -detection. Like that. We run the code, and there's some mistake because it has to be spam detection dot. I believe that's the correct syntax. Exactly, there we go. So now we are building the Docker image, and it's going to finish building in a second. And once we go inside of our Docker desktop and we go to images, we should be able to see that we have the spam detection image right here. Now all we have to do is run this image in a container, which we can do by clicking on this button in here, or we can do it programmatically by calling docker run --rm spam detection. So spam detection will now be the name of the image whenever we want to run or use it. Now what will happen is this code is now not running locally on our computer. It is running inside of the Docker container that we created. And we can see that by default, because in the Docker file we defined, whenever this container is run, by default, we're going to run the spam detector script. This script ran, and we got the accuracy of 96% actually this time. So now the last question is, how can we run the predict function inside of this Docker image rather than locally? Well, the way we do that is like this. We go docker run --rm spam detection, and rather than saying dot, we're simply going to define the exact command that we want to run inside of this container. And it's going to be Python predict.py and this example message here, free money now. So we can do that, and looks like we made a mistake like this. And now, okay, so it's going to give us some warnings, but at the end it tells us this message is not spam. And if you wanted to, we could also push our image from here inside of Docker desktop into Docker Hub by clicking on push to Docker Hub. And boom, just like that, with just a couple of commands, we have deployed our machine learning application using Docker in a Docker container.